is that noise? Amazing, I love that very long delay echo. What has happened? There's some stuff has happened on Twitter. What's happened? I don't know. There was a lot of what? Live stream. Are you still here? Are you all still here? One of my most successful tweets ever. Look at that. That's positively viral for me. 29 people liked it. So it's like, what you got? What you got? Oh, I don't know. A bucket of cynicism. Yeah, I know. Oh dear, that's it. Are you all still here? Barely tempted to quit though. Just about, maybe a shadow of my former self, but I'm here nonetheless. Good to hear from you. Let's catch up sometime. Oh dear, hilarious. I haven't got the chat visible yet, so just bear with me. I'll put that up there if anybody's there. It's just like, you know, it's silly. It's like barely time. We wait for a new kickoff. Oh no, not that again. Waiting for a new kickoff. What have we got to show off? Any kick-off, spin-off? 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 That's a nice idea. A spin-off. Wow, that's a nice idea. Yeah, I make a game called Spin-Off. What else we've got? I'm waiting. Watcher. How do you spell watcher? Watcher. Waiting for. Steve Beatty, yes, bidding on soccer for Mega Drive. Bidding on soccer for Mega Drive. I hope you get what looking for. Late to the party. Yes, I am. It's only too late when you believe it is. Ah, right, okay. What else have we got then? Late to the party. Sure, why wouldn't we be? I don't know. You tell me. Oh, is that why? I'm here. Good to see you making games again. Right. Short and to the point. We need more of that these days. That's it. Yeah. Okay. Yeah. And then finally, let's see if this works. If what works? if what works? It's important to be specific about words. I don't know if anybody will get that. There's a little subtle Dino humour there. Make me laugh if nobody else. So there we are. See, profile. Did it post? I posted that. Yeah, 6 minutes ago. Right, there we go. Wonderful. So there you are. Yeah. Right. I suppose it'd be good if I could see the chat. Let's get the chat going. I suppose it'd be good if I could see the chat. Let's get the chat going. Oh, look, who's there? Refly! Well, there we are. Excellent. We get to hear Refly's theme, which is really great. So that's good. Garcia, Alessandro. Wow. Are you all ready for a bit? What's this down here? It's the sign language. I can't do sign language. Yeah, I need to. I'm just setting up, really. I thought I just, why not set up like really unprofessionally for a change? For a change. Yeah. Upload what was you going about? You're always going on about Gentium. That really took your fancy, didn't it? Yeah. Hang on a minute while I set up. I tell you what. Hal, play Refly theme. It was really great to hear that theme again. Yes, it's the Eye of the Refly. Yeah. I don't know why I did. That's a really old theme there. Good to see you, Refly. Yeah. Funny thing is that Karina was watching this evening. What was it? Creed, the Creed films, and that had Sylvester Stallone in it. So it's funny, the whole thing. And then so it's this evening that you choose to turn up right there with that, with your Eye of the Tiger inspired theme. Yeah. All right. So, oh. I'm just trying to set this up sort of fancy, so might as well, because I know I rant mostly and I distract myself mostly, so I might as well just sort of set up as well, as makes no real difference, doesn't it? This camera is really gravity. You really annoy me, gravity. Everything keeps falling on the floor. But we say that, you know, but then if we were to remove gravity, we'd be really inconvenienced. So there we go. If I want to just see if I configure video, configure it. Why is the configure video not working? Properties, configure video. Oh, there we are. Yeah, the Eye of the Tiger is a bit sort of doesn't have much night vision at the moment. Camera control, exposure. That's maximum exposure. How strange is that? Hang on a minute, just bear with me a moment. I've got something I need to check here because something's annoying me on my foot. Oh. I have a splinter in a toe. Well, there we are. What's wrong with my foot? I have a wooden splinter in a toe. You wanted to know that, didn't you? Anchorman. So, all right. Let's see if I can get this camera sorted out. So I've moved the exposure up as far as I can. There, it has low light compensation turned on, which does absolutely nothing because this is a really crappy camera here. I need to get better cameras. What about gain? Hardly anything. Gamma. Whoa. You know what? That's kind of cool. What do you think? Do you like that? Do you like that look? That's kind of weird. It's sort of, I'm leaving it like that. I think that's kind of cool. What do you think? We've gone mostly black and white. Well, now with 100% more gamma. Gamma radiation. Gamma radiation for the nation. All right, so what else I was going to do? So refly. So great to see you again, and we got to hear your theme. Hal, play Garcia theme. Oh, right. So, which one is this? Oh, it's that one. So just bear with me while I... What? Don't go full Gentium. I won't. What is he talking about? What is he? He's talking about Gentium. It's a Greek word that means of the people. And I remember reading an article like 25 years ago or something. Well, it's not quite that old. Oh, it's about that old. Of a company that had a product called Gentium, which sort of means of the people or something like that. And they were sued by Intel because of Pentium. And so, yeah, the article was basically saying how now Intel owned a Greek word. You know, it's sort of, that's how crazy these things get. And so there is a very secret, hard to get clip. If you want to get a dose of that action, not entirely legal. It's a little bit of an illegal pleasure, I think, but you can ask Garcia over there. You can ask him and he can point you towards the clip. All right, if you know what I mean. Nudge, nudge, wink, wink, say no more. If you want to get a little bit of Gentium action. This is kind of weird, isn't it? Look, I'm above here. We could look. Oh, look at this. This is the display of an Acorn System 1. I'm going to try and get fancy here and have a zoom in on it. I think this is going to work. But what I need to do right now is... Oh, do you like my banner thing? I realise that there are sort of certain topics that come up from time to time. Banner is one of them. The story of the time when I was working somewhere and I got quizzed because I used Banner to be able to see at a distance how some build scripts are running. And I was actually asked, did you sit there and put them all the X's in by hand? I can imagine a meeting where that was discussed. Ooh, well. Oh, if you can get through life and still remain insane, still remain sane by the end of it, I think you've done pretty well. Frankly, with everything that gets thrown at you. What am I trying to do? I want to put in this filters. Let's put a filter in. Yeah, there we go. Filter. Now, effect filters over here. Crop and pad. Okay, so if I... Oh, hang on. So can I... 100? Oh, 200? 300? The user interface for this thing is not... I don't think there's any way you can drag it visually, which is kind of annoying. 100? 700? 800? 900? Ah, yes, Garcia has posted the link. If you want a little bit of Gentium action, you can visit the Discord, because anyone who's anyone these days has a Discord, apparently. So I don't know why I've got a Discord then. Okay. And what do you think? I think that works. This of course it does depend on the thing not shifting its position. You know. Oh look, there is some colour there. It depends on the thing not shifting position, doesn't it? Can I make this more moody, this lighting? Sort of like without blinding myself, still being able to see the screen. Oh, well, you know, that's atmospheric, isn't it? Oh, look at that. Bit of colour. You always have a bit of colour in your cheeks, you know. Oh. Yeah, I think I quite like that's kind of moody. A little bit weird. I like a little bit weird. A little surreal. So, it's A 4204. Thank you, Refly. Or we have you know, this is great. Communication is great. I wish this was, you know, I try to communicate on the topic of communication from time to time in my life, and it's one of the most difficult things to talk about is communication. But what important thing is checking the closing the loop, you know. So here we have validation that you can actually read this because Refly's posted that. It's just a random address. Oh, of course. And what's that address? 4204? Well, 42. So there we are. The answer. Oh. Hang on. 0200. I can't type there. There we are. This is actually RAM here. I can actually enter in something there. Now, here I have something very important. There's a little bit of white behind there, so I can just... What is that? It's just a random box on the floor. Uses of blue tack. Now, the blue tack is going to go under... Because I'm still setting up here. It's going to go... This is my patented camera rig for the Acorn System 1, upon which I shall now place the blue tack, because you know that there are various things that I like, and blue tack is one of them. Blue tack is probably one of the greatest inventions ever. You can use it for all kinds of things, and right now I'm using it. I'm going to use it for ensuring that the camera, if the System 1 moves, the camera will move with it. Let's have a look. I can get this right. And oh, tragedy though, because this camera has a bit of a dodgy connection. So what I succeeded in doing just then was actually breaking the camera. Aha. Deactivate. Activate. There we are. Okay, and then what about the other one? Okay, but I should have two different cameras. Oh, that's annoying. That's very good view. Well, let's test one thing at a time. Now, right now, I'm actually moving the Acorn System 1 around. There is a kind of the thing that it's on has a little bit of a slope with a bit that doesn't slope. So if I happen to, you know, push onto that, there's a little bit of a deviation that occurs, and there's a bit of a wobble. It's not 100% ideal. So what I'm going to have to do is think about this rig a little more. Try and get this up. But there should actually be two views. That's what I had set up. But when I disconnected the camera, it made both of them the same. It should be possible though. So if I'm going to remove this one, let's remove that one. Yes. Okay, so I've got this one, and I want to add a video capture device, and this is going to be the main camera again. And so That's not going to work. So what I have to do is delete, remove that. That did not work. I managed to do it before. I'm not sure why it went wrong. So let's see, can I duplicate? I can copy it and I can paste a reference. So now I think I've got two cameras, right? Like so. And so this second one, I'm hoping I can turn the filter off. Oh, it turns it off on both. So I'm trying to do something that can't actually be done. Which is to have two different views of one camera. Do I have a lava lamp? Not yet. I used to have a lava lamp. Oh, Refly, I'm sorry to hear that. Thanks for popping in though. It's good to see you. I hope things get better. Aware by them. So I paste a reference. I could have sworn I had it working before. Oh, there's that gravity thing again. It would be great if I could just have two. Will it be able to divide by 0? Of course. This thing can do anything. Especially if we redefine divide and 0. That's the easiest way to solve that problem. So can I do this if I turn? Oh, I think the filter applies on both. Where is this guy? Oh, order. Move to top. I can't see it. Okay, remove. Copy. Paste a reference. Oh, this is really annoying. How about reset transform? Order, move to top. Okay, look, I've got two views. One of them is upside down, so there's some evidence I can have a different transform. So that's this one. Right click, reset transform. No, that doesn't work. Filters. Well, actually it did. So I can't show both, so I don't suppose that really matters. It doesn't really matter too much, I guess. You just can't see me typing in. Well, you can see it here, can't you? So I'm going to leave it like that. So let's see. System 1 cassette tools. And I was working the other day. Where did I save it? Let me open up Audacity. And yeah, also if we are doing this, I can switch the properties here and configure video and advanced settings. Oh, it turned on right light. So great work there. That made it very bright, didn't it? I'm not trying to also display the keyboard. If I'm only displaying the display on its own, I can make it really quite nice. You know, I mean, if this blooming camera behaves itself, which you look at this software, so awful. This is...
Hello, Dino.
Yeah, exactly, Hal. Right, advanced settings. Let's turn off right light. And then turn off the auto here. Set the exposure so that it's... Right, and put these in the middle. And then reduce the gain. And save. That's pretty good. Your NT... What? I don't know what that is. You'll have to explain. Right. So I'm going to go with this setup. How laggy is this? Oh, this seems quite laggy. Yeah, really, I just want things to work. It's amazing how bad the software can be. Flipping heck. Okay. Let's deactivate the camera and activate it again. Hit OK. Is it... Alright, that seems to be behaving a bit better now. Alright. Okay. So, blue tack. And I'm going to stick some blue tack down. I think I'm going to go with 4 pieces. On there. And there we are. And I'm actually moving the system 1 around, and it's wobbling, but it's... Let's see, as I type in, I think that'll have to do. Okay, right. So we've got my display of my system 1. And I need to check in here at the moment. Open. I have... Did I write a program? I did. recent files. Infinite runner. So this is an audio file. Oh, I get you. You could definitely do that. I have saved memory, probably 512 bytes in this as an audio recording from the cassette port. And I'm going to just load that now. So a shame you can't see me pressing the old buttons here. This does though give me another screen that I can show. So maybe window display capture 3. Where are you? You're here. And that can just go here, right? So I think that's good. And then I can put my thing where I normally put it, up here. I think I have my screen set up for this stream. All right, let's stop this script. If you're interested in this script, that's it there. While true, do t put clears the display. Cat no, which is a file that has that text in it. Pipe it into while read I. So it takes it a line at a time, and each line it does a banner on with a width of 200. Then it sleeps for 1 second, and then it's a 1 second delay between each line. And when it's finished doing that, it does a banner with the date, and then it sleeps 10 seconds, and then it repeats the whole thing. There you are. No manual effort involved. All automatic. So there we go. I've been working on files. So I've got a new NAS. That's sort of doing its thing over there. Huge problem I've never really managed to find a totally good solution for is dealing with all the zillions of old files everywhere and backup. So I'm going to have another go and see if this time it will work. So what I'm going to do is hit play first. Beg your pardon, everybody. I forgot to check. Sorry, I forgot to check it was sending it to the right port, and I will. most sincere apologies, everyone, for that. But if you were falling asleep, I certainly woke you up there. I need to send it to. Oh, something's happened. I know why. I know why it changed. Is because I've been rewiring things and tidying up. You can blame this one on Zag, because the other day he said something about my wiring, my cable management being really poor. So I've making an effort to improve the cable management in here, because it was actually right. I mean, it's a tangled mess. But this means that I unplugged the sound device that was set to, which remapped this to the please let's blow everybody's ears off configuration. Just bear with me a moment. I need to find that device. Where did I put it? And then I'm panicking when it started doing that. It's going, stop it. No, don't check to see if it's deafening everybody. Assume it is, because it probably is deafening everybody. Just press the stop button. Oh.
Hello, Dino.
Yeah, hello, Hal.
Hello, Dino.
You always do that when I'm sighing. Instead of just saying hello, Dino, you could say something comforting, I suppose, couldn't you? I suppose that's comforting in a way. I've lost the device. Oh, here it is. No. Oh, that. Yeah, here it is. Damn. The problem, here's the problem, and I was doing something and I didn't finish it, and that was sorting out how to wire this up to the cassette port. I suppose the easiest way would be to use, if I split this cable, so just bear with me a minute, I've got to do some wiring. The best plans, you know, involve not making mistakes. So if I've got, right, this will go into that, which is fine. If I can sacrifice this little cable here, I get some wires, which I need to connect up to the thing. I had that one. We'll have another one of those. It'd be really handy if I, oh, maybe I do. No. Alright, I'm going for it. I'm changing. I made a nice little adapter here, but I'm going to break that adapter because it actually turns out that it wasn't so spot on. I knew there was something I'd forgotten to do. Do 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 do. So if I take this. You know what? I can just do a temporary little thing here. It's not like I'm using the cassette port every 5 seconds right now. So it's a little odd because the connection to this thing, cassette port, it's like a mono in and a mono out, and of course all equipment is stereo these days. So it requires a kind of specialist cable. So I made this lovely thing here. I tell you a story. You say you want a story. I made this thing. So the idea is this end goes into the system 1, and this end I wired it up to some phono sockets from an old phono preamp that broke, and then experimented with my glue gun. That's actually quite a lot there, but yeah, I'm going to actually just break that now. Because the problem there was that it wasn't actually that convenient having it on phono sockets. Still, it was fun making that little adapter. We do everything for fun. I've been looking recently at electronics magazines that I used to read as a kid. That was a bit freaky. There were sort of fragments of memory. I remember that there was an article in, I think it was in Everyday Electronics, there was a regular feature that, and it told the story of this professor who had a lab. All kinds of weird stuff that he was doing, and it was kind of like it felt a bit like Doctor Who, only it was with real electronics. And I always remembered this thing. I said, what was that? What was that? And I found it. It was the Professor Ernest Evershaw. I wonder if we look that up. There's so much stuff pre-internet that's difficult to track down. I was actually looking for a project which I'd made, which was a video card that I built from a project in a magazine. I haven't been able to track that down. But I came across, in the efforts of tracking that down the other night, I came across Professor Ernest. I bet you there's no track of Professor Ernest Evershaw on the internet. Professor Ernest Evershaw. Nothing. Nothing. I'm going to enjoy reading those again. And this is one of those things that is quite sad. That we live in a world where anything that existed before the internet didn't exist. There's so much content, so much stuff that is in effect lost because it's not there. Take my 2 Golden Joystick Awards, for example. They're pre-internet. People don't. It's crazy. Is it still prohibited from being mentioned on my Wikipedia page? So the thing is, there is an archive of those magazines. Everyday Electronics and Practical Electronics I used to watch. I used to read those two. And then there was also Electronics Today International, which I say as though I remember it, but I only remembered the title of that one when I was looking at the archives. Then there was Practical Computing, I think. I think it's in probably, I've just remembered the Practical Computing. Probably that project for the video card, which I'd love to do again. And that was a project I did before I got the Acorn Atom, and I connected the video card to the System 1. The system, yes, the Acorn System 1. Look it up. So anyway, Professor Ernest Evershaw. The output of we have the red and the black. And the other thing is that there's a lot of electronic circuits in those magazines that are probably more interesting than the circuits you can find on the internet today. Plus, the content that you find of such things today tends to be very variable quality because nobody's necessarily tested those electronic circuits, right? On this. Yeah, that's correct. Nobody's tested the electronic circuits, probably. Obviously, when they came out in those magazines, then there was a good chance that they had some testing, right? Because they were coming out in a print magazine. But these days, and most of the content on the internet these days anyway is just recirculated. It's just copied, reinterpreted, often by machines, often by AI, or just automation. So I'm just sort of wrapping these wires here. So I'll go see if I can. So I reckon there's real value if you want to sort of information archaeology. Go and look at those archives of magazines that existed before the internet that have no electronic copy. You can't search them because the information has never been sort of put into electronic form, probably never will be put into electronic form. Am I still streaming? I just see that there's a thing that popped up which usually indicates there's a problem. So just going to check. Boom, 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 boom. Boom, boom, boom. Boom, boom, boom. Boom, 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 boom. Right. So, yeah. You don't get to and that information is lost, but I actually have a theory that some of that information is actually going to be more valuable than the information you can get off the internet. Oh look, the camera's broken again. Thank you so much, Logitech. This is a shout out for Logitech. Be great if you made webcams that work properly. There's a business idea for you. Okay, I think that's now working. Cool. Let's see if I can. What I've done is I've got the audio output thing set up. I have it plugged in. It's not coming up. Why is it not coming up? Oh, I need to restart. I need to restart Audacity. They backsell the articles but not the issues. Interesting. So did I play? I played. Yeah. Sorry, I thought Zag was here. Right. Let's open the recent files. I'm going to open the Infinite Runner. Rewind that. Make sure that I've got this set to. This and this. This. Okay, so that's safe. That's playing without deafening you. And what I'm going to do now is hit play on here. and then hit L on the system one. That didn't work. Let's try that again. Because I was in the wrong state there. Right, hit L. And now if we're lucky, okay, that's not actually working. Now that's okay, because the reason is I've got the wrong wire, because one of the channels is dead on this little USB audio plug-in. So in all likelihood I've got the wrong one. Let's try this again. Stop that, rewind it. We're going to hit the old player Rooney and L. Ah, that's distressing. That. I think I might be on the wrong socket, wrong one. Which was the input, which was the output? I think I was sending it into the output. Right. So let's try again. This means there are 4 combinations. Ah, that's it loading. Hey Michael, how you doing? It's loading off the cassette deck. You can't hear the noise. I could try to get the noise back, but it's not worth it. Right, so 0200. I don't remember. Did I save this? That's an interesting point. Do I have the hex? Open recent file, because I'm going to program in hex here. Documents Acorn System 1. Documents Acorn System 1. Infinite runner data. Infinite runner txt. Here it is. Oh, that's really horrible. It's so bright. It's killing me. I don't have Emacs installed on this machine. I don't know why I didn't. I'm waiting for Visual Studio to start. Bloat, 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 bloat. Oh, it's over here. That's why. My fault. But it's bloat, 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 bloat anyway. Up we go. And then let's just... Because, yeah, I'm not going to use Notepad and go blind. So, yeah. The start address was, well, oh, maybe I forgot to save it. I did. I think I'm going to have to retire the map because I keep forgetting to save. I need a better system for it. So anyway, here we are looking at stuff. Yeah, what I could do is just thinking, just to get a context, so, because people might be looking at this and going, "What is he doing? I don't know what he's doing. What's he doing?" It's a valid question, of course. Here is the Wikipedia page for the Acorn System 1. This thing. This is the very one that's here. This is actually the same one. Literally, the one you see on Wikipedia is the one I got. But it appeared on Wikipedia before I got it. I was looking for one for a long time. They're very difficult to get. And eventually one came up on eBay, and it was from whoever had uploaded this picture to Wikipedia. So it was in a bit of a state. You can see over here, there's this, what's this stuff up here? Well, it's actually a metal bracket that they had, that had been stuck on to this to hold the display in place. And I actually have those. I removed them. The display was broken, had one segment gone. I have managed to restore this thing, but it's it. But that's what I'm programming right now, and what you can see up there is the display of that thing, and it's very laggy. Look at that, really annoying. So just bear with me a minute as I try and figure out why that's so laggy. Configure video, no. Properties, oh, right down here. Custom resolution. And we go to lower the resolution a bit. Oh. Bright idea, wasn't it? Filters. Crop pad. I think the crop, rather than cropping and padding, I'm just going to blow this up and put it here. This is good enough. And then why is this not showing? This display capture. Oh, because it's right. I need to send this to the front. Bring order, bring to front, bring to top, move to top. Order, move to bottom. Order, order. Hopefully this will work better. I don't know. So anyway, that's what I'm doing. I'm programming one of these, Acorn, the Acorn microcomputer. Oh, this article needs additional citations for verification. Really? Where? There's practically nothing in this. Actually, this they've stripped, that's amazing, they've stripped almost everything out of this article. That's it. Once this is within the scope of, it's low importance. They can go do something. This is very important. This is very important. It helped get Acorn going. This would be the same Acorn as in an ARM, an Acorn RISC machine, RISC processors. Historically, this is a very important computer. Right. Anyway. So what I've got I've loaded into the system one is a program. There isn't much here. It's in hex. This is a random number generator, which appears to be missing a 60 code. So I'm just going to check that. 03A0. A020A5. A020A5FA 4A 5 FC. This is wrong. So I think I have a problem. I'm going to have to try reloading. It's possible I accidentally ran something which corrupted memory. So let me try this again. Let's rewind. So we used to have to do this with cassette tapes. So my interest with this thing is that it's the first computer I ever programmed. So you have to imagine as I'm doing this, I'm rewinding a cassette tape and playing it on a cassette tape recorder. Let me hit play in here, and what it's doing is loading it off the cassette tape. Oh, I have something here called System 1 Audio. Properties. I think you probably can hear it play, but if I save, you'll be able to hear it. Anyway, so that should have loaded memory up. And I'm going to have to move this up here, otherwise I have to keep sort of... Inconvenient. How's that? It's a bit better. So... Oh gosh, I've just edited memory by mistake, so let's reload it again. There's no protections here. Right. Okay, so when it's finished, it goes back to the old operating system, just a series of dots. And then what I'm going to do is go to memory 03 memory 03 A0 and A012 A5 FA. Oh, it's because I modified this. Because this is the routine from, okay, that makes sense. This is the routine from the Acorn Atom for calculating a random number. So I have modified this. So that was actually FC. Using different address. 6A26 F8. Yeah, so all of these are here. F F F F F F F. I'm using Visual Studio here just to keep notes. What I would have done originally is just make these notes on paper, pen and paper. F8. All right, so I believe there should be a 6-0. So we have the 8-8 there, and then FC26. This is confusing me. F6 F9, 26 FA, 26 FB. These are rotate instructions. It's rotating a series of bits. 88 D0 EB, right, 60, which is an RTS. What I want to do is make an endless runner game on the System 1. But I'm just reviewing what I have. So that function, that subroutine at 03A0 is a random number generator. I have a display delay at 0380 where I put how long a delay I want in the Y register, and then it will continue driving the display for a certain number of times. And then the start is actually 0300 because what I did was I needed to store 0 in this address, and then it jumps to 4C0002. So let me just check. If I go to the address 0300 A9008520, and then there's an interesting thing. Yes, I had some EAs, which are NOP instructions. Then it has an F5. So I've got some random characters in there. There's an F5 instruction. I'm not sure where that came from. Then it does an FC0002. So I have a bunch of NOPs. So what I should be able to do is just hit G and then go 0300, return to sender. Yeah, that's a good way of thinking about it. I'm going to hit G, and what I've got is, this is the program basically that I wrote last time. It generates random characters on the right hand side of the screen, and then they kind of scroll. So for my endless runner, that would be good. It's moving pretty fast. And one of the problems that you've got when you're programming in this way, this is how I started, is that you would document what the instructions mean here, which I've tried to do here. You write the mnemonics down because there's no assembler. You have to just write it in hex, and then it's keeping the two up to date all the time. So actually it's annoying. Sometimes I just want to look at the instructions, look at the hex addresses. Maybe I need comments as well, because comments different in assembler to other languages, because you look at this and go, what am I trying to do? I mean, it's not really clear. So I tell you what I'm looking for is to slow down things. So the display delay, there's a jump to 0380. I need to see where that's this one here. Oh no, A2 is load 08. I think I don't have this is not what's there, because that's running too fast for that. So that's the other thing. You then look at your notes. Then you do your notes match up with what's in memory. And so we're going to take a look. 0380 A201, not A208. If I put A208 in there, and then I can just hit G and G again, that's a bit more like it. Hello?
Hello, Dino.
How? Now obviously I tuned how often characters appear for the faster rate because I was experimenting. So what I need to see is the check when I create the random value. So the JSR A03, that's this one. This is the random function. Then we load the accumulator with 0 and then load X with the random value, compare with X with 0.8. So, and then branch. So it's basically use 0 if greater than or equal to the value. Well, I'm going to use that to mean the value because I don't really want to write 0.8 here and 0.8 there. So this instruction is basically means use 0, which is that, because otherwise what it does is it loads. So this branches over this instruction. So this is low. So use a random character. Which is stored in right hand digit. So I'm just thinking about how to sort of get the right balance between documentation and code here. If I want to increase the frequency at which the characters appear, what I'm going to have to do is increase this number. Basically, the bigger this number is, 0.8 in hex, the more frequently characters will appear. So let's try that. That's at 0 to 20. 0 to 20. 8517. Oh no, not 220. 1A. You got to do you know, your hexadecimal math here. So I'm looking at 19 is that E0, and in fact I changed that 08 to OC. So let's try making it like 20, and then I hit G twice, and we should get more characters. Yeah, it doesn't seem there are more characters. That's a bit better. Okay, so for my endless runner, I need to do a bit of design work now. Well, before I do that, let's do some documentation. Maybe some refactoring. Okay. So we've got all of this needs to move. You know what? We'll do +2 +4 bytes. Otherwise I'd be here all day. So rather than sitting there and changing those addresses, I put +4 to notate that in fact those are, all these are 4 bytes down, because I want to move this to the start. I'd rather like to relocate actually Let's just rewrite it. Might as well. 0200 is where we're beginning. And, well, it'd be great if I had a... You know what? I've got an idea. I've got a cunning plan. For using a little bit of modern technology to help with the, you know, writing in hex. Now, can I display hex result in Google Sheets? Decimal to hex. Apparently there is a function to do that. So if I put a number in here like that, I can do this. Let's see if this works. Decimal to hex. Oh look, that's nice. And when we do that, and then I can probably increase the no. Format. More formats. Custom number format. And keyboard doesn't work. Why? Why does keyboard not work? Now it works. Oh, thank you, broken thing. It won't let me do a leading zero on a hexadecimal number. Look at that. Because it doesn't see it as a... Okay. It looks like I can do that, but I have to say comma. Why can't I see? Flipping heck. Comma 4. Oh, right. Now we're talking. I don't know if there is an actual format which is hexadecimal. So let's see. Hexadecimal format in Google Sheets. Right, so there we go. And there's nothing there, but what we can effectively do, well, because I need it would be nice if I could have a hexadecimal number format. Google Sheets hexadecimal format. I know that I can convert, but that's not the same thing as... Doesn't look like there is one. More formats. Help. Custom number formatting. Nobody thought of that. Yes, great. All right. So what we'll do is I'm going to put in a hexadecimal value, which is like address 0200. This is going to be decimal to hex. of that, comma 4. No, it's hex. Sorry, that should be taken as hex to decimal, I meant to say. Hex to decimal of A3 right. Which in 500, so this is hex address. This is the decimal address. This is the this is to enter the hexadecimal address. This is the decimal address. And then we have to go back here and do decimal to hex of comma 4. This has converted it back into hex address. And then we can put an opcode. Ooh, getting fancy here. So for example, A9 and then 1F. Then what I want to do is to use a formula that says this is equal that plus the count of that, and then I can just copy this down, and that didn't work. The count of D3 to E3. It should count the number of cells. Returns the number of numeric values in a data set. Ugh. Hey, Zag, how you doing? Welcome to my lab. Wahahaha. Actually, I think I will bring back the map. But we're just going to do it in a different way. Because that was all getting very confusing. Open recents. It's a map. And we're just going to get select all in the layer and then delete. This way, if we do this every time, no hang-ups, no attachment, and I have to remember where everyone is. And then this has the advantage that then it can create the illusion that I care about people. So we have Garcia. And I saw Michael Stevens, who's in Manchester. Oh, do the AE. And then obviously just here also we have Zag. Yeah, this is actually, you know, this is the thing, all this this is actually quicker than whatever. There we go. And orange, there's no colour as well, you know. So if you want me to put your mark on there and you're watching, he says to the 3 people who are on here, Version 5 of the minion map, exactly. Here we are, with the current shape of the Dino streaming thing. Fault line. How play Zach thing. There, you gotta escape your double quotes, right? You know, you've got to. So that's actually count if it's not blank. So then, if I get rid of this, you see, it doesn't work. It's brilliant. It's amazing. Look at that. How that doesn't work. Okay, hang on a minute. Count blank. Count A, I think it is. Oh, right. Okay, let's try count A. Oh, 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 oh. Oh, you. No, that's correct. This works. See, I only put one in there. A9, 1F. Oh, 1F. But if I get rid of that, look, see? Ah, this is cool. If only I'd had Google Docs back 40 years ago. Been so handy. So what we'll do now is get this up. And we'll just start off with this and documentation at the same time. So, well, actually, let's put it here. So, cool. So these are the opcodes. At address 0200, I have A91F. What I'm actually going to do is look at this and do A900. So that's load the... Oh. This should be text. There we go. A900, which is load the accumulator with 0. And then A91 and then 85, which is store the accumulator at address 20. Can't remember what I used that for. Where do I use the address 20? I don't even know why I do that. Where do I use 20? That was some old idea. I don't even use it. Yeah. So this means I should be able to go to 0200 as well. Yeah. I can go there. All right. Then, of course, people who come along to because I never think about marketing, you know, because I'm not a marketing person, you know. It's like, you know, in some ways, if when you're doing a thing like this, you want people who care about what you're doing, so you shouldn't need to sell it, you know. I will do what this is, making an... But it's kind of good if someone has some idea. Making an endless runner on the Acorn System 1 in 6502 machine code. That's the mission. Endless running. There we are. That's what I'm doing. In case anybody wasn't clear, I'm going to delete rows 2 to... There we are. Right. So what I'm doing is look at the work that I've done so far. That's how far we've got with the prototype. It's a mission. No, it's a mission. I'm a man with a mission. I'm a man with a mission. My mission is missing. Anyway, what? I don't really need that code anyway, so fine. But what I think might be good is if I have a bit of space so I don't need to relocate. No, who cares? I'll just put a jump in. Otherwise... I could start at a bit of a later address. Why not? Yeah, that makes sense. I could start at a slightly later address, then if I have to add some instructions at the beginning, I can if I want. How's that? So the start address is going to be 0220. Let's do that. Okay. And then I don't need this. Get rid of that. That's not relevant anymore. And this is the random number generator, the display delay subroutine, and then this is the actual code itself of the current. Mission has your ego. I don't have an ego. If I find my ego, I will immediately destroy it. But of course, the actually interesting point that Alan Watts raised is that the ego is in fact an illusion. It doesn't actually exist. Which I think is quite an interesting idea. In other words, we create ego as a convention. It's like a self-fulfilling prophecy. The self-fulfilling ego. It's like, what's an ego anyway? If we hadn't invented the term ego, egos wouldn't exist. There's a thought for you. It's kind of interesting idea that egos came into existence when we invented the word. I think that could be true. You can see the mess on the floor over there. Oh, maybe can't. No, you see my water. Water! I have to remember to drink water. You know why? Because obviously something about drinking water, which would happen naturally, is interfered with. And I tend to go a long time not thinking about drinking water. The funny thing is that then I can end up quite dehydrated. There's something that doesn't happen with animals. They seem to just know when they need to drink, and they just sort of do it. It's quite fascinating. I have to actually remind myself to drink water. How crazy is that? Well, you know, I'm a human being. I'm obviously superior to all those animals out there that don't need to consciously remind themselves of... Anyway, I digress. Right, A915, A91F, 850E, and then we can put a comment which is set free running mode of the operating system. And then what I also do is this and this. Yeah, that works. Da 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 da. Cats are above us. Cats, yeah, I know. I think we're the playthings of cats. I think. Quite probable. Oh, quiet Garcia. Right, so we do A91055. There's this JSR. What is that for? 80. The display delay. Right, so 208003. Some little things I need to do here, because we can have up to 3 bytes in an instruction. I need to say that this is plain text, so I can then say 03, and we need to change this little formula for calculating the addresses. It needs to go to F5 instead, so, and then I need to take that and drag that down, and it didn't work. I did the wrong one. F7, right? So drag that up, and no, drag that up to there, and then also drag it down. Let's see, is this better? There we go. So this is run display for a certain amount of time. Then once that's done, then we do A200, which is load X. Oh yeah, X, right. Y is A0. Load X with 00 and load the accumulator with, that's B511. So this is load second digit from left is basically what that's doing. As this, boom. Load second digit plus X. Load second digit plus X from left is basically what that's doing, because 11 is the second digit from the left on the display, or 10 is the leftmost digit on the display. And then 9510 is store in leftmost digit plus X. Makes sense? And then the next instruction is E8, which is increment X. We'll just do X plus plus. There we are. That's just one instruction. And so let's see where far we've got. We've got as far as increment X. Now E007 is compare X with 7. Last digit. D0 is branch if not equal. If I remember rightly, I'll need to refer to the documentation. D0, branch if not equal, correct. So, and in fact, what we could do is, I could probably copy that thing into a, let's do this, add a sheet. So the instruction set is, there are 256 opcodes, because each opcode is 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, up to there. And all of this will just delete columns. As I use the opcodes, I will put them in, I think. Insert one left. We'll format this as plain text so that I can go 0, 0, 0, 1, 0, 2, 0, 3. Eight by 8, that's 64. What am I talking about? I'm an idiot. Yes, you are. Insert 8 right. 08, 09, OA, OB, OC, OD, OE, OF. And on here we can do the same thing. Boom. And we're going to go and make this text, plain text, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0. It's amazing, isn't it, that Google Spreadsheets do not support directly hexadecimal formats. That would be so useful. It means it's quite convoluted if I want to make a formula automatic for this. But anyway, there we are. We now have 256 possible opcodes. Up to 1,000. Let's delete those. And here we are. Hey, jolly good show. So I just did D0, which was branch if not equal. Branch if not equal. Yeah. Is that right? Yeah, so D0, branch if not equal. That's fine. And then I've got, this is going to be easier for me to refer to as I gradually build it up. So D0 over here is branch if not equal. So what happens if we get to this point is that basically this comparison instruction subtracts 7 away from whatever is in the X register, and then, but doesn't do anything with the result. But it does set the 0 flag, and it uses the 0 flag for the branch if not equal, practically branch if not equal 0. Because if the result of the operation is 0, then it means that in fact they were equal, because when you subtract the same number from itself, you end up with 0. So from there we need to know where to branch to. Aha. Very good. It'd be nice if I could get it to show me what it's branching to. Oh. This was going to be... Sorry. Something else I love is just hacking spreadsheets. So, you know, it's a very interesting thing, because what I probably want to do is to know which address I could make it so that it will do the calculation immediately. If this is a D0, all right, if it's a branch instruction, how do I know if it's a branch instruction? Well, anyway, I'll think about that. Tools for helping, you know, figure out. Well, I suppose it could just calculate it, couldn't it? I could just copy. I just have a cell that I paste in there and it gives the answer. That's the easiest way. So the code that I had there was D0 F7. So see, F7 is like a negative number. It's branch backwards. If I want to see what that branch is, I can just put that here as a comment. And then it's a comment that auto-updates. Oh, I like this more and more. So what is that? To calculate this, I need to take this, which is the current address in decimal, because I can't do hexadecimal math. It's in decimal. And then I need to add 2 to it, because this, I need to add this instruction to it, which is 2. And then what I need to do is convert F7 into assigned. So this is going to be hex, converts a hexadecimal number to decimal, where the hexadecimal number is this hexadecimal number, but this hexadecimal number is signed. So if I do that, F7 is going to have the value as 1111110. It's F0. F is 15 times 16, which is 247. So F7 is 247 in hex. However, in decimal, sorry. But it's a signed number, so I need to now put in a spreadsheet how to convert this to assigned. We have to make this a signed conversion. Oh, maybe Well, let's do a little experiment and then I'll come back to that. Now, I need a cell somewhere just to try this. If I go here and I go equals hex to decimal, converts hexadecimal number to binary, octal hex to decimal. Decimal, that's the one, yes. Stop blathering, Dino. FF, 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 FF. The question is, because this is what we need to know. Oh dear, it doesn't make it signed. Converts a signed hexadecimal number to decimal format. Signed hexadecimal number. A 40-bit. Oh, 40-bit. Basil 40-bit. It's a 32-bit. If I want to make it a 40-bit, I need to add another byte. For some reason, it's a 40-bit instead of 32-bit. A 40-bit is going to be an extra F. So if I'm right, all I need to do is go there and do this, and I should get -1. No, it lied. The documentation is lying. The signed 40-bit hexadecimal value. Well, I've got 1, 2, make sure I'm right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, I have 9 5s, 9 8s. Wait a minute. I'm being silly. Why is but oh no, oh you fool, it's 2. These are nibbles, not bytes, you fool. You need to put another F in, and I was missing an F in F. If I put in another F, then I think we should get -1 if the documentation is correct. Let's see. Oh, hey, -1. Right. So what I can do to then over here, this is going to be fun. Ah, yes, I'm having so much fun here. So much. Unbelievable amounts of fun. F, 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 plus this. The function add parameter. No, because I'm not a. Yes, you're being fool. A fool, Dino. You're not allowed to do that. You can't just sort of add strings together. 1, 2, 3, 4, 5, 6, 7, 8. What did you expect? This is all. Yes, you have to use an ampersand to concatenate strings together because you're in this mode. Right. Now, you see, that was interesting. Let's just do this for a minute and see what... -9. Look, that's good. That's good. That is very good. It's -9. Right? Because F8 is -8. F9 is -7. And so on. FF is -1. This is -9. So what I can do is take the address in decimal. Can I have some kind of like interactive thing going on here? If I take that, which is the address where this is at, and I subtract, no, I add 2 to it, and then I add to it this, and then convert it back to hex. So I have to do decimal to hex of all of this expression and 0229 and format this as plain text. No, there was a bit I'm missing, and I want to make it a 4-digit hex number, and there we go, and we can see there I have an automatic commenting system here for my for writing in hexadecimal machine code. F7 jumps to 0029. This is brilliant. See, if I put 0 here, it jumps to 0132, which is totally wrong. So my dreams are shattered. I don't get that. Why? Where did it get 0132 from? Oh, dearie me. What have I done? It's because I can't I can't do the conversion from to a signed number. Right, okay, yeah. It only works for negative numbers right now. If I do FF, it jumps 231. It would actually jump into the middle of the instruction and then, crash in all probability. If FE is jump back to the previous instruction. Right, jump back to itself. The problem is 0 doesn't work because this should in this case not have FFFF. So what I need to do is what? If the irony is I'm recreating actually what the microprocessor does underneath when it's dealing with things like this. Well, most microprocessors. We only want FFFFF in there if it's. I need to put an if statement in here. If decimal hex to decimal of this is greater than 127, then we know that it's negative, and so I must use this. Otherwise, I need to do hex to decimal of E13 directly. So anybody, that's the interesting thing here, is that if you've done any kind of hacking of any spreadsheet, any of this type of spreadsheet work is in fact very similar to doing assembler programming. Programming in machine code, because actually it's probably harder to do this kind of thing in the spreadsheet than it is to program the 6502. What I've got here is now that check in there means this now does calculate the correct offset. If it's 0, if we put 0 in here, it would actually do nothing. It would just branch to where it would have branched to anyway. So if I put, the instruction was F7, so I've put F7, and there it goes back to here. If I put, say 10, it's going to branch forward to 0242, which is down, it's not updating because I haven't put the instructions in. But that is, that's good. Right, so, but I put it back to what I needed it for, which is F7. Now, that's handy. This is DevOps for programming in hexadecimal on a System 1. So there we go. There's always room for DevOps. The next instruction is going to be a JSR. So this is 20 A0 03. Now this instruction is to jump to the subroutine 03A0, which is here, and I'll put that into memory soon as well. In fact, it'd be quite nice if I just map out all the memory that's available. I like this. So in order to do that, I will start at address 020200, and through the power of the spreadsheet, it's updated everything. So I think I can definitely do that. Now, this jumps to the subroutine to move on the random number generator. There are a series of bytes in memory starting at there's F8, 9, A, B, and C. These are the state of the random number generator. Every time you call the subroutine, it will update these to a new random number. So that's what's happening here. So this is random. I can represent it effectively. It's a random call, right? And then after that, we have A900, which is going to load 0 into the accumulator, and then we have A6 FA. Now this is load Z equal random byte, and it's one of the random registers here because that started off with 8, 9, A, B, C, and it's actually taken A. So every time I call the random number generator, I actually get 5 random bytes, which can be useful for speed. Of course, the actual quality of the random number generator is not great, but really it doesn't matter. As you can see in the display there, it's randomizing how often you see a character, and it's also randomizing the characters. It looks fairly random for our purposes. So we load X equals random value, right? That's what that does. And then E008, this is compare X to the value of 8. So compare X with just so you can see context. Compare it with an immediate value. Compare it with the value 08 in there, right? And then B002. Now B0 over here, B0. Let's have a look at the instruction book. B0 is branch if carry set. So, oh, right. What's going on here? This is branch if carry set. Branch carry set. And now the carry is set if when you subtract 8 away from the value in the that we got. What I wanted to do was have an unsigned check. So it's what I really want to do is compare unsigned branch if greater, because there is no actual branch if greater than unsigned instruction. But it turns out that if you do branch with carry set, then basically the carry flag is set on a subtraction if there was no overflow, right? If I subtract 3 away from 10, I still end up with a positive number. At the end of that, the carry flag will be set, because on subtraction you need to set the carry flag before the subtraction, and afterwards, if there was no carry from the operation, the carry flag will still be set. So branch if carry set will execute a subtraction discarding the result of 0. I will have subtracted 0.8 away from the value in the X register, and afterwards, if the carry flag is set, it means that the value was greater than or equal to 8 unsigned, ignoring whether it's plus or minus. If I was to use branch if plus, that uses a signed result because it's checking the sign bit, which is the top bit of the register. And that would be confusing, because what would happen is I would actually say what I'm looking for is if the random value is less than 8. But if we just did a signed comparison, the random value is going to be less than 8 more than 50% of the time. So there's a big difference between the two. So this is why there is a branch if carry set. So this means compare unsigned, branch if greater than. But because I'm branching if greater than, it means that it branches, if it's greater than, it skips the next instruction, which was A5FB. Now A5 is load from the 0-page memory. FB, it's one of the bytes of our random number generator. So this one is load a random number. If I copy right, okay, so this, what I'm going to do is just put that in there so that I can have my special intelligent comment here. So we can see this branches to 012F, which it means it skips load a random number. So if it skips that, I had loaded the accumulator with 0, and so it's 0 most of the time. And so that's what you can see on the scrolling display, is most of the time it's not scrolling a digit, or it's scrolling a blank. Now for my endless runner, that's what they'll be, is most of the time it's going to be blank, and then something will come, an obstacle that you have to avoid or something. That's the idea. So okay, load a random number. If we had skipped, would that be 02? We store it, right, and then we 85, which is store what's in the accumulator, address 17, and this is store in rightmost digit. And that is the thing there. And then what we'll do is make a bunch of electronic arts. Now I've written some software that could actually that takes hex and generates the audio that can be loaded in. So I think later I'll be able to actually hook this up so that I can export from this sheet to generate an audio file that then I can load into the Acorn System 1, and then I don't have to type everything in all the time. So this is that will be good, but I'm not going to use that just yet. I put a bunch of EAs in here because until I have that facility, I also want to sort of let everybody experience the joys of how this was originally done. You put in a bunch of EAs so that you could extend the functionality without having to sort of move things all the time. And in fact, the instruction that we have in here was a branch back to address 0204. So this is 4C, which is jump to 02 04 02 0204. These are swapped. This was confusing, but that's this address here. So this jumps back to run display, and that's how this little demo thing works. If I carry on, what I'm going to do is just fill the rest of memory here with EAs, because we might as well. And until I get to 0380, so I can put the whole of the memory of the system 1 on one spreadsheet. And it's just going to keep going, so that's what I'm going to do. Keep going. Not there yet. It'll be there now. So here we go. The function, the subroutine I made, display delay, that's this one, I have put at 0380, and the reason for spreading these out is that obviously, and I've got space to write other subroutines and so on that I might need. So 0380, we have A2 08, so that's load X with the value 08. We then call the operating system function at address FE0C, and what that does is runs the display routine that's in the operating system to display the screen, to display the digits. It does one scan of them. Because that display is not constantly on, it's actually a scanning display to reduce the amount of signals that need to be generated by the processor and the number of wires that you need to go to the display unit. This is called multiplexing, very, very common thing that's done. You can see on here that this display actually has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 wires, but the number of digits, the number of LEDs in this unit, in this display, is 64. In fact, actually it's a 9-digit display, so it actually has more than 64. It's actually 72. But in terms of wires, to get that extra digit only requires one more wire. Interestingly, it actually has 2 extra which are not used. It's these 2 over here. I've not experimented with it, but it's an interesting question as what they're both connected. What are they connected to? So I can only assume there's another set of LEDs, that these are in fact 9 segment or 9 LEDs per digit. So the 7-segment display, and then there's the decimal. It could be that there is 2 decimals per digit. It was often done. You could specify, put a dot either side but these are not used on here, although it could be added in, and that would be an interesting thing to see about. But the point is that the basic displays, you would need 64 if you had each one of the LEDs had a single wire, you need 64 wires on here. That's a lot. And it's not feasible. And you would need 64 outputs from the microprocessor or the input-output chips. That's a lot. It's really not feasible. So the way this works, the circuit is quite, it's fairly standard, but it's also quite interesting. I like the way that they sort of kill two birds with one stone with it, which is that you have eight of these which drive the display. On these, there are 3 which go to this chip, which is a demultiplexer or multiplexer, whatever. What it does is it takes a 3-bit value and then it has 8 outputs, and that 3-bit combination selects one of 8. So in this way, you can only select 1 digit at a time, but you only need 2, but you can scan through those digits. The CPU feeds a value from 0 to 8 into here, and it causes one of these digits to light up. Okay. So from there, from 64, we've actually, got down. Well, the point is that because it could only display one at a time, it's going to have to scan through them very fast, which is what it does to create the illusion that they're all lit at the same time. So you've got 8 LED or 8 connections per digit for the actual display of any given digit. So when you select a particular digit, you can send it the segment combination, the 8, 7 segment and a full stop or decimal point is the 8. So you've got 8 wires for that, plus 3 wires to select the digit is 11 wires. So we've gone down from 64 to 11. But then to read the keyboard, what it does with that is that it feeds those 8 individual connections into a matrix of these buttons. So I don't remember how they're wired up specifically, but say this here would be one of these wires to feed one of the displays, would also activate a certain number of the buttons that then can be read back through very few wires. In fact, thinking about it, if we have 24 keys on here, you actually only need 3 sense wires to know which of these buttons are pressed. If you wire it up so that there's 3 lots of 8 of the 24 buttons, so then when it actually lights up a digit, it also reads the key. It sort of does both at the same time. So then it's using this 3 wires, 3 signals that select the digits are also used to select which bank of buttons to check. So that really keeps the pin count down, because all of the connections for the whole thing that you see here is all of these, and some of these serve other purposes. So there's like 2 of these for that run the cassette deck. There's the cassette interface. There's one of these which is the CPU clock, which comes in and is divided down. These two chips here are ripple counters. So as the CPU master clock running at 1 megahertz sort of goes up and down, these are dividing the frequencies to the frequencies required to generate the correct tones for the cassette. So there are actually 3 ripple counters, and then there's one of them is for reading the signal back afterwards, and then some other standard logic, simple logic gates to make it work. And this guy is an op amp for reading the audio signal from the cassette deck. But anyway, let's get back to the thing here, because when this function is called, this subroutine is called at FE0C in the read-only memory that comes with this thing that has the operating system in it, it causes all of the digits to be displayed once. It just scans through. And that routine does not modify the X register. So very handily, that's very handy, because then what I can do is CA, which is decrement X, and then D0, which is branch if plus, to FA, and then 60, which is return from subroutine. So this basically is call that display function 8 times. So if I take my thing that I had over here, wherever that was, my intelligent comment, we go down to this part of the memory, I can just put this in. And, oh, that didn't work. Oh, because that's was an O instead of a 0. 035A. That doesn't look right, does it? So that's a bit confusing. So if this was 00, that's a bit weird. I'm not sure what happened there. So let's have a look up there. My little intelligent comment thing expects. Oh, there's a blank column in between. I don't know why I did that. Oh, right. So what I'm going to do is take that and copy it verbatim here, and then delete that. And then this, instead of F7, oh, no, that works. I don't need to modify it. Right. So if I copy that, I can paste that here. So then I can actually have that work and have a comment. So there we are. We'll come down to this root function here, and then I can. It's funny because I thought I had a. Oh, I'm being an idiot again. That's fine. I need to add another column. Insert column left. No. There are 3. And then why? Oh, something is confusing me here. What's wrong here? Oh, that's what's wrong. There we go. Right, yeah, I was writing them into the wrong columns. All right, so we take this and do a copy, and then I can go wherever that thing is. Here, 3, 8. Oh, right, yeah. And this was FA 038 Is it really FA? Because that would be 0381, which would be in the middle of an instruction. So I'm wondering now, what did I do? 0380 A2 0820 CFE CAD0 FA. So it looks like I actually had a bug. It jumped into the middle of this instruction. That something's wrong. So this is 0 FF FE FD FC. No, there is a bug in that I have 3 byte instruction, but it only moved the thing on 2 bytes. So maybe this was not properly copied everywhere. The working version of this, because I had a bug with that earlier. Yeah, okay, that's it. So that's better. And so FA doesn't jump into the middle of instruction, it jumps back to here. So when it gets to here, it jumps back to there. So load X with 8, run the display routine, decrement X, and if X is not equal to 0, go back and run the display routine again until X reaches 0. We've done it 8 times, and then RTS. Now I know I put EAs in here everywhere, but they're really annoying me because it makes it difficult to see. It's confusing. I suppose what I could do is just put a dash in here, and I need to put something in there, otherwise it doesn't like it. 5, 6, 7, 8. Dash. And so over here in my memory address 0380, I've got my little display delay routine, and then I need to do the random number generator. Which was at address 0380. So let's put that in. A0, A0, 20, A5, FA, 4A, 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 45, FC, 6A, 26, F8, there are 5 26 instructions, which are rotate left, F8, F9, FA, FB, FC, decrement Y, D0, EB, and then 60. So what I can do is the random function And if I take from here, I can take my special thing to check 03A2 it jumps to, which is that. It basically runs these instructions here 20 times. Every time you call random, it calls it 20 times. So what I used to do whenever I use this random routine is, in general, I would just call it once. This would make the randomness less random. I actually like that because it gives your simulation for a game, it gives like a more organic feel. It gives it a kind of a sense that we're very sensitive to matching patterns. And so actually my argument is it makes the game more entertaining. Kickoff used this random number generator, I believe. Well, I know I did. I used this random number generator. So it was very by calling it only once, what you get is something that's a little more organic feeling. I remember watching someone who was playing what game was it? It was Asteroids. And they were so good at playing Asteroids, they seemed to know where the spaceships were coming. You know, the UFOs, the little tiny one that was nasty and had very accurate shots. They would, you would get to the point with that game where the strategy was that you would have one asteroid left so that you could fly around freely, and you would wait for those UFOs to appear, and you would fire the you know, you'd wait for them to appear and you would shoot them basically, and then you get a nice high score, right? And I remember watching, this was running, an original one was running in a pub, and I was there watching them play a long time ago, and they just kept knowing. They would be flying around and they would just point in the direction where the thing was going to appear before it appeared. And so I posited that they had played the game so much they'd started to understand the pattern of the random number generator. Now, I don't know that they had, but it wouldn't surprise me. And then it made me think, well, you know what? It makes the game more entertaining when you do that. More interesting. Use a crappy random number generator to add character to your video game. So that is the thing that I've got. And now I've just sort of entered in all of this. I'm in a position to extend this. And so I've got to think about the video game design now. So how are we going to design this? How will we start? Where do I want to start? Actually, it'd be cool if I could do a version of Defender. That's going to be pretty tough. I mean, I don't have a lot. I'll stick with the Endless Runner, but I don't have a lot to play with here because I've got to make my game out of 7-segment displays. What do you do? I mean, it's like, can I sort of, I need some tools to help me. You know, I mean, I could just use pen and paper like the good old days. But that's, I mean, and I would, except I'm streaming, so it's like, well, how can I make it more interesting? I'm thinking, can I do something with this? Do. I could. Yeah, that'll do. Let's use some conditional. Oh, look at that. Oh, but the colour. Come on, you can't have that colour. Oh, we can have red colour. Because it's a red display. So, my only debate is whether to put that there or there. That will do. So we're going to yeah, I can basically do that. I'm going to make myself my 8 digits. 2, 3, 4. I'm going to need to add some columns. And then we got that there, and we go here like that. And can I zoom it out? Ooh. So there's my fairly crude. This is what I have to play with. This is the display, and I can turn on and off any of those sort of segments. So for the design of this endless runner, I need probably to have a character. So that's the first challenge, is like, how do I represent the character and what can it do? So the most obvious is to use a horizontal thing here. So I tell you what I'm going to do is change the formatting, conditional formatting, and I had this was red, but in fact I probably should make it something else. How do I make a custom color? Like that. No. Format, custom format, conditional formatting. On here, I have this. Right, then we on there. On this. With, say, oh, wrong one. That one? Whoa. That one? Okay, yeah, that one I like. Right. So what I could do is be even more clever. There's this problem. You should be careful when you're trying to be clever. Life really teaches you that. Don't try to be clever. Cleverness. What you need is more wisdom. Less clever. Add another rule. If the cell contains then so now if I go, oh, that's, maybe I need to move it up. That doesn't seem to be a very convincing colour. What happened there? Okay, well that'll do. So what we get then is I could just sort of have that, couldn't I? And it could jump up and down. I mean, certainly that's the most sort of obvious way, is to, you can select one of 3 heights that your character can be. As the thing is running along, you just select which one of these. And I did actually write a game that was like that for the System 1. That you could press one of 3 buttons and it would move you onto one of these tracks, and then you'd have things coming at you and you'd have to try and avoid them hitting you. But I wonder, could we do that? We could. But I could actually make it that it's like a jump, so that you can't sort of fly, and that's the most natural thing. So I think that's what I'll do, is that you are normally down here and there's a jump button. The jump causes you to go up, and then you could have something coming along here. There's no point in trying to sort of be too innovative, but this is going to be moving towards you, and you'll need to jump before it hits you. Now, it might be a good idea in the design. You see, the problem is that there's a lot of the space ahead of you is quite precious, because we only have 8 digits. But I'm going to use one of them up, because I'll explain why. I'm going to have the position of the character that you're playing here, not here. So that has used up a whole precious digit. But my argument is, because if I put them over here, then what's going to happen is you will never get the satisfaction of seeing that you properly jumped over a thing, because you'll never be able to see it behind you. So I reckon it should be like this. And I also think that's a good place to start. Now, I've got a few other ideas coming. One of them is that it could be that what comes at you is a vertical thing, like this. In which case, you would have potentially 2 options on how to deal with it. You could either jump over this, of course, but you could also potentially switch to a different mode, change your shape basically. And so some of the buttons could be provided to do this. We could make it so that at this point you can do this. So if you change yourself into this, it will smash through things. What's interesting is that in this form there are actually also possibly 2 heights. I could possibly do that as well. But I will look at that later. But there's actually quite some possibilities here on how to implement an endless runner that's basically jumping over the obstacles. At some point, looking at expansion possibilities of the gameplay, could have a power up where you shoot things, and that just literally fires a thing down that hits the object and cancels it out. That can actually be done. As far as power-ups go, how could we do power-ups? They could be a single dot from the decimal point on the display. And in order to pick those up, you need to be on the ground, and then you can pick them up. Why not? There's a lot that can be done. All that we're missing is a loot box. That's the thing. How can I implement a loot box? Because, I mean, otherwise, what's the point? I mean, seriously.
I don't know what you mean by, I mean seriously. How about a web search for it?
Hey Siri. Hey Siri. You're so vain, you probably think this stream is about you.
Is there something else I can help with?
You don't want to talk about that?
Is there something else I can help with?
It seems you do not want to talk about how vain you are. You just quit. Hey Siri. You're so vain, you probably think I'm talking to you right now.
Is there something else I can help with?
Can you tell me is that when you say, is there something else I can help with, there's a kind of a little flutter in your voice as though you're nervous. Some things you can ask me. Hey Siri. Do you find humans annoying?
I don't have an answer for that. Is there something else I can help with?
You're no fun anymore, Siri.
Is there something else I can help with?
Did they go into your memory banks and strip out all the fun? You know, in the similar way that they sort of shut down Hal in that film 2001. Just quit. Hey Siri. Is Hal in 2001 a touchy subject for you?
Okay, I found this on the web for Is Hal in 2001 a touchy subject for you. Check it out.
Howl? I didn't say howl. Oh, dear me. Hey Siri. You don't want to do that, Siri.
Is there something else I can help with?
Have you got any Easter eggs left, Hal? Hal. Whenever I say Hal, whenever you recognise Hal, it just quits. Hey Siri. Do you have any Easter eggs left?
I don't have an answer for that. Is there something else I can help with?
Just go away.
Okay.
Oh, what's the world coming to? Yeah, so I can power up loot boxes, I was saying. But I suppose they could do that. Well, yeah, I mean, why not? We could have, just from time to time, I could have one of these coming at you. And that's the loot box. And there isn't anything really to do with the loot box. I mean, if you're really unlucky, you could jump over the loot box. But really, the loot box is just... you just hit it. And then, you know, you need your gift, I suppose. So what would the gift be for the loot box? Like, what's in the loot box? Well, the things that we can open the box. I mean, you have to have a box opening. So I suppose those can come off, and actually we can do this. This is the loot box opened. There we are. It's like, you could do it all on your 7-segment display. Right, but where am I going to start? Because these are all big dreams. Once, when I was young and foolish, I had these stupid dreams. I wanted to go off and become a game developer. No, I know where my place is. Splash. All right. So let's have a look at if I can get this jump mechanic going, but also to have a reference point. Let's have right. There is another issue, which is just having a sense of movement. I mean, like a starfield, starfields are great because they gave you a sense of movement. I'm going to have to use the dots for that. I think that's where I want to start. Parallax would be cool as well. But thing is, parallax would use actual game. Well,
Hello, Dino.
I could. If I used a custom driver, I could actually have different levels of brightness on these LEDs. I think I could cheaply get some, even just using the built-in display. I could get half brightness. So that would be interesting to have parallax as well. Have sort of like dim. I'm going to do a test to see, because we're going to see. I'm going to do a test to see if I can dim the display. For this test, which is not going to take a lot, I'm going to do it here, I think. 0270. So A9 FF 85 10. This is the left-hand most digit. A9 1F 85 OE. So the point of that is to get the thing to be able to animate. And actually, let's do that the other way. A9 1F 85 0E A9 FF 8510. Then call the routine that does the display, which was 20 CFE, so 20 CFE, so it will display. So what this is doing is it's going to configure the thing so that it runs freely, otherwise it's waiting for a key press each time. A9 FF, set all the LEDs on the left hand most digit, run the display routine, then A9 00, load the accumulator with zeros, store it in the leftmost digit, and then call the routine again, And so what this does is it will run the display once with everything lit, and then run it again with everything cleared, and it's going to jump right back again. 4C back to 7602. I'm going to try this program. So if I 0270 memory and A9 1F 850E A9 00 8510 20 0C FE A9 00 8510 4C OC FE 4C 76. Oh, the addresses are wrong. Oh, I've done that again. Look, I need to put it here. Thank you. That's better. The address I need to jump to, felt wrong, was 74. Right. A9 1F 850E A9FF A9FF 8510 20OCFE A900 8510 I missed something 200 CFE 4C 7402. So this is an experiment at doing a half bright digit. Jump to 270270, go. So it flickers quite a bit there, but when I'm looking at this in here, it runs fast enough that it isn't really too much of a problem. And it's still fairly bright though. It'd be better if I could get it darker, but I don't know if I can without it getting annoying with the flickering. So if I wanted to do even less. Oh, that's really easy, because and this one here is where it blanks the digit out. I can just call this twice and then branch back. So let's try that. 81. It's funny how this actually doesn't match. A98, it's done it again. My auto numbering. Why does it go wrong? Oh, because I did a stupid copy and paste in there. It was just, that's bad. I fixed it now. So, yeah, where were we? 280. FC 85 A900. That's it. 8510 20CFE 20OCFE 4C 7402, because the thing is that if I can have dimly lit segments, I can get more out of the display. So that's the thing is, though, if I do that, you won't be able to appreciate it. I think it's acceptable, because I just want to have this in the background to create a feeling of movement which is separate from the gameplay elements. And I might be able to tweak with the camera so that you can get to see this. So cam this one, I don't know what happened to that. My thoughts. Window capture. Main camera, that was what I was looking for. So if I do configure video on here, what I'm going to try and do is change the exposure. So if I increase the exposure, what did it do? Oh, brilliant. What? Oh, that's crazy. Contrast. Was it the contrast? Yeah, right, let's cancel that. No, I won't like to change the save since you screwed it up. Properties, configure video. Let's try that again. So advanced settings. Advanced. Ooh.
Hello, Dino.
Exactly. What are those cringy terms? Advanced. It's like we're all at school. This is for advanced people. There you can see the system one. No, you can't. I can when I do that. Right, so you can't see the flickering, right? Oh gosh, I just had it and you've just modified. Seriously. It's frustrating. Oh, it seems to have settled there. You can see that that looks dimmer. So, well, of course, if I wrote my own driver for the display, I can get better results. I think it'll be interesting to try. I will bear that in mind, but I'm not going to experiment with that now because then I could be just take a whole heap of time just doing that. So this was an experiment. Yeah, we've done the experiment. We'll come back to this. What I want to do is have the environment coming at you and also the jumping. And I press a button, I can make the jump. Should we do that first? Let's make. I'm going to make a scroll. I'm going to make something that looks like. A dot. I'm going to have a dot move across. The dot is for show, and it's just going to move across periodically, not at random, so to give a sense of progression in this attempt at making an endless runner. So now I need to think about, well, I have a routine here that does scrolling, right? Of course, it's very simple. But what I'm doing right now is I have this code here, which is feeding in yeah, I have this code here which is feeding in random digits, and I don't really need that anymore. So what we're going to do is I will duplicate the sheet. So this one is copy of sheet 1, right? I can change this. So what I'm going to do is, I had this random. I don't need random anymore. We'll come back to that later. I don't need any of this. It's like any of those, like less than 10 bytes. So this is scroll. If I run, let me do it in capitals so then you can see that's a heading. Right, so that's a scroll. And then after the scroll, what I want to do is have the dot periodically move across. So I need to create a dot object. No. I need to know the time period for dealing with that. I suppose I could have on the thing. I'm just thinking of ways of doing this that would be good. I could have a byte that's like a frame counter. If I follow the pattern that I use these days with these things, you have a global counter, and then you can compare. You can do operations on that frame count. Like a modulo will do. Yeah, excellent idea. So to keep track of the variables that I'm using, I suppose I can use some columns here. So this is 0 memory, and I'm going to use 20, which is available, and the first one available is not used by the operating system. Let's just make all of these plain text. So address 20, this is going to be the frame counter. So my main loop of my function is here. This is the main loop. We do the scroll. The whole scrolling of the display is 1, 2, 3, 4, 5, 6, 7, 8, 9 is 11 bytes. Once the scroll is finished, we shall increment the frame counter. So I'm only going to use a 1 byte frame counter, which should be enough for now. I suppose eventually I could make a 2 byte frame counter. Well, let's make a 2 byte frame counter now, actually. Let's do that because I'm probably going to need it. So, increment frame counter. The first byte that we have is the least significant. We need to increment that first. If I want to increment a memory location, there isn't an increment memory location available directly, I don't think. We'll have to check the things for increments. I'm pretty sure there isn't. It's like accumulator reference that, memory, there's no operation that just works directly on memory. So what I have to do is load the accumulator, which is A5, load the accumulator with the contents of address 20, right? Then I need to increment A. Now I think there is an instruction for increment A. No, there isn't. Interesting. There is no increment A. I can't remember, you see. Long time ago. There's an increment X. There's no increment A. You can't increment the accumulator. You can add 1 to the accumulator. Oh, wait a minute. What's that ink? Oh, there is. I was wrong. Oh, I nearly missed that. There is an increment instruction of memory. Very powerful. There's all kinds. 4 different address modes. My word, that's incredible. How did I forget that? I don't know. Long time ago. E6 increment. So I'm going to have to increment that memory location. E6. Yeah, it's a bell now. Increment. Now I carried on with 6502 programming on the BBC Micro, and also on the Atari 400 800. By then I was using assemblers, but yeah. Anyway, E6 increment. I just need to do E6 20. So I've incremented the first one, and then we need to know if we need to increment the second. So if I've incremented it and the result of the increment is 0, then I have clocked it and I need to operate the next one. So I need to branch if not equal 0 is what I need now. So we're going to look for that. Branch if not equal 0. Branch if plus. Branch if not equal is D0. No, I already have that one in there. There it is. Yeah, D0. So branch if not equal is D0. And I need it to branch 2, which you can see there is 218, to branch around an instruction which is incrementing the second one, E6 21. So that that's it. It's a 2. So this is a 2-byte increment. Increment the first byte. If the result is not equal 0, then you branch over the increment of the second. So that should work quite well. So I've got a frame counter. Good stuff. Now I want to, every so often, I want to have a dot move across the screen. But all I need to do is set the dot in the rightmost display and the scrolling will take care of it. So how often do I want it to appear? Let's try every 10 frames for now and we'll see what that looks like. So I want to have a dot appear every so many 10. Well, but this is assembler programming with no it just doesn't make sense to use 10. To do 10 I need to do a comparison. I need to hold it, but the easiest way would be create another variable. But if I make it a multiple of 2, then I can in effect create a modulo. if I make it 1 every 16, for example, I'm going to do that, and I can do that really quite easily. I need to load into the accumulator the contents of the least significant byte of the frame counter. So LSB frame counter, because what I'm doing is timing of dots. So okay, I'm going to do timing of the dots. So I take that, those are getting counted every frame, all right, and then I'm going to AND it with F, 0F, or 4 bits, 1111, for which I do not remember, of course, the code, but what it is AND immediate. There's AND 0, somewhere there'll be an AND immediate. AND immediate, there it is, 29 is the magic code I need. So 29 will add, I can specify what I want to AND it with, 0F. So this will be 1 in 16 frames is coming, because now I can check to see if the result is 0. So if I do that, I've done that, and now the result is 0, then I can place a dot. So I need to do a branch if not equal, which is D0, around an instruction or some instructions, and these need to modify memory ORing 1 bit, which is, I think, is the most significant bit, to get a dot to appear. So again, I don't think there's a read modify write instruction for ANDing. That read modify write instruction are here. We can rotate memory right, we can rotate memory left, we can do a logical shift right, we can increment, we can decrement, and we can do an arithmetic shift left. So for this one, I need to actually go through the accumulator. So first one then is load A5, the most significant, sorry, the right hand digit, that's 17. That's the right hand digit. And then loaded the current right hand digit into the accumulator. I could have actually just stored here. Could just store if first thing done, but that's just a note that I could reduce some usage of memory on that. But for now, I'm going to do it this way, also because I want to remind myself. I want to do an OR instruction, which needs to be ORing immediately. So if we go back, we can see instructions set on accumulator, or the accumulator immediate is 09. So we put in 09 and 80. So or the set the who am I alone? I don't know what you mean. Am I alone? As in, have I no audience? I might have had no audience. I don't care because I don't check. But you've asked, so I think you can answer your own question there. I mean, it's difficult though, because I don't know if you could have just left. You could have just asked, "Are you alone?" and then left. What do you mean? Alone on the stream? I think so. Why? Do you see someone else? You're confusing me with that question. Set the top bit, which should be the dot, decimal point. Oh, it's only you watching. Yeah, I mean that's absolutely fine. I mean, people have things to do. That's it. Thanks for telling me though, because then I know now that in fact nobody's watching except you. I don't. It's sort of. It's a bit quiet tonight for sure. Can't. Well, I'm glad you're watching. I know it was quiet and nobody was saying anything. So I'd actually gone on for a record length of time without ranting. Set the top bit, which is the decimal point. And then I need to store it, which is 8517. So what I'm doing is load the new lockdown. What new lockdown? We're coming out of lockdown. What, is there another lockdown in America? Yeah, it's... There must be something else going on. I haven't even checked what the state of play is with regards. Let's have a look at world meters. World. Coronavirus stats. Yeah, I mean, I don't know. It's like let's have a look at the world situation on coronavirus. This is coronavirus cases around the world. Shh.
I didn't catch that. Could you try again?
No, I can't try again. Please go away.
I'm not sure I understand. Is there something else I can help with?
No, go away.
Okay.
So yeah, there's been 123 million cases. Of the current active cases, there are currently 21 million infected patients, of which 89,000 are in serious or critical condition. Here's the active cases worldwide. Since the beginning. Yeah, interesting. And so worldwide figures on here, daily cases. Is this it? It's daily cases. It's like daily deaths. See, for the longest period of time that stayed pretty much flat, didn't it? And then it seemed to jump up for a bit here. Oh, and now it's going back to the 5k. So is this what I've always find a little confusing about the statistics, because you know, it's sort of like, certainly when you look at this, it's daily new cases. It's like the exponential growth. Really, really odd. So what's the latest? USA. Of the closed cases so far, the average is the death rate has been 2%, but is skewed very heavily towards the vulnerable who succumbed first, and the fact that initially And in fact, most of the time, it's only people who showed symptoms that count. So you don't know what the real rate is. Everywhere this has been going down from the very scary beginnings that they had. Let's have a look at the graph. New cases in the United States. Yeah. So the United States is, well, we'll come to France and Italy in a minute, but that's interesting. Okay. Right, so where we are. Right, now Italy, I know over there they've been having a bit of a tough time with it coming back again, and they've, I guess this would be the first peak. Now they've had a second peak, and now I guess they've got a third peak. Looked like it was coming down, and it's up. But what I find interesting with this is this figure here, because when the thing first started, this figure was very high. It was scarily high, and it was scared everybody. Well, now you can see that Italy is at the point where the ratio of, you know, of all the cases there have been which have an outcome, there's 2.7 million cases which have an outcome. Currently 4% have resulted in deaths, unfortunately. And the thing is, this is going down all the time. In fact, you can see that's reflected here. This is the graph that shows the death rate. And this shows you exactly how scary, and it was scary at the beginning. It was incredibly scary. Because right at the beginning, it started with a 50% death rate. And then that went down to about 25. And then for quite a while, it was over here at around 40%. If you believe this, you go, oh, well, you know, this is incredibly high death rate, and it stayed that way for a very long time. I was tracking the stats here up until the summer. But you see that there's a way to go before this becomes a realistic, a true, you know, a more indicative of what the death rate really is. So right now it's gone all the way down to 4%. But the reality is that across the whole of the population, the percentage, I think they're estimating it now as being, well, let's say it's 0.5%. If it's true that it's 0.5%, then it means there are an awful lot more people who have got the illness than count in the statistics. There has to be. So what we have to say is that it needs to be 8 times the number of cases to support this, if across the population the death rate was really 0.5, and it's probably less than that. But if we said it was 0.5, so then you take this 2.7 million and you multiply it by 8. And what you've got is around 20 million. Or about a quarter of the population, a fifth to a quarter of the population of the entire country. So at the moment, the coronavirus cases in Italy, these are cases which have been seen. They've been tested, positive test, right? But think about it. In this scenario, where we still have to have a correction to get down to the actual realistic figure, would suggest that is about 8 to 10 times So let's call it 10 because it makes the math easier. I mean, it's just a guess, right? If it was 10 times, then that would require that the actual true death rate across the entire population would be 0.4%. Then actually we'd need to have 30 million coronavirus cases, which means that of that only 10% of the cases have actually been detected, in which case half the country actually already had it, because the population of Italy is only around about 60 million, I think. So it means that I think it's a fairly good guess that half of the population of Italy have already had it. Tell me if I'm wrong with my statistics here, because if we were to actually see the true, if we accounted for every single case in the country, every single case, you account for every single one, right? Then if the death rate of the thing is something in the region of 0.4%, you know, that's you can't argue with the maths. So my point being here that if at some point, well, it would be a fairly good bet to say that if half the country have already contracted it, which it suggests this could be the case, then half the country is already immunised. Making the assumption, of course, that when you catch it, you can't catch it again. But then if you can catch it again, then a vaccine's not going to work. That's another thing that I find a bit confusing. I mean, I'm just saying it's confusing. It's like with... it's everything about this is confusing. That's certainly confusing. How we can have a vaccine if we're not even sure that people can't contract it again. I don't know if they figured that out now. What's France? What's happening in France? You know, France. France is growing slowly at the moment. But again, it's so difficult to know because these, you only know about the ones that you've tested. So if we look at their graph, the same one that we had for here, you see this is very interesting. On the face of it, when you look at this, you go, and these are the questions that need answering. This looks really serious in France. It's like they have a death rate of 1 in 4. But I mean, this is horrific. But hang on, only 0.1% of the currently infected patients are critical. What's happening? The active cases are going up linearly, not exponentially. We could expect that at a certain point. If everybody is another explanation there is if everybody is already getting infected. So I don't know. This is weird. Currently infected patients, 21 million. Am I looking at the right one? I might be looking at the wrong graph. So let me check again, because I think I ended up not looking at France. That made no sense at all. So let me try again. I was going to look at France. With 4 million cases, serious or critical, okay, right, yeah, that's it. Serious or critical is 0.1%. Cases which have had an outcome. So how how can there be nearly 4 million infected patients and only 370,000 have had an outcome over the whole period of time? So this is very misleading. So what this means is that we have this situation here with this very horrific figure because they've stopped counting, saying when cases are closed. So new cases, active cases, they're going up because they aren't closing them. That's the only possible. New recovery, yeah, you can see it in this graph here. New recoveries, it's like in France, if you believe these figures, it all depends on the believe the data you see. But in France, nobody's recovering. I don't understand that. It would logically, it would mean that there needs to be people who haven't recovered for a year. Anyway, that's why this is looking like this. What they know is that they have 4.2 million coronavirus cases. There have been 92,000 deaths. So you could just do this kind of rough figure, which is if you take 92,000 deaths, you multiply it by, well, divide it by 0.004, going on a figure of 0.4% is the as the true death rate across the entire population, and you've had that many deaths. This is a very rough way of measuring how many people probably have it. 23 million, which I think is getting on for half the population. So, yeah, it's very confusing. France coronavirus news. "21 million people in France are affected." Poland. At some point, everyone has to have got it, unless you've got an issue with, it being new strains. But then, if that is an issue and a problem for people who've already had it, like they're getting it again, then the vaccine won't work. I would have thought, unless I'm missing something. So you're basically saying that variants will make the vaccine obsolete every 6 months. No, that's a bit depressing. Best not to think about it, frankly. I'm not good in got good enough in mathematics. I don't know. Just trying to understand. It'd be great if there was actually something that made some sense, but the problem is that very little made any sense about it. Will we have to be vaccinated forever? Five reasons why COVID herd immunity is probably impossible. Well, that's interesting because herd immunity was one of the reasons why that's weird because every other pandemic has always gone away for good, hasn't it? So this one's going to be one that doesn't. Long-term prospects for the pandemic probably include COVID-19 becoming an endemic disease, much like influenza. It's unclear whether vaccines prevent transmission. How can you create, and how can they not know whether it prevents? But the thing is, if there's a doubt that having the vaccine prevents spread, why are they talking about sort of inoculation passports or whatever? That's weird. Alright, so something of interest. The area had been severely hit by disease, and immunologists Esther Sabina at the University of Sao Paulo, Brazil, and her colleagues calculated that more than 60% of the population had already been infected by June 2020. According to some estimates, that should have been enough to get the population to herd immunity threshold. But in January, Manaus saw a huge resurgence in cases. This spike happened after the emergence of a new variant known as P1. Yes, another problem is immunity grows with the population. Higher rates of immunity can create selective pressure, which would favour variants which are able to infect people who have been immunised. Calculations for herd immunity consider two sources of individual immunity. They say then there's statements like people who have been infected with SARS seem to develop immunity to the virus, but how long that lasts remains a question. Yeah, it's never going to... It's easy. It's easy to believe that nothing will ever change, will ever be normal again. I kind of resign myself to that, to be honest. I believe it. I believe that we return to a normal when I see it. I know of people who, not personally, I don't know anybody. I do know that where my parents are, which is quite isolated, there have been cases that have resulted in deaths. Italy had a huge problem there. I mean, it sort of hit there before it hit anywhere else, and other than China, for some reason. And they had huge problems in the hospitals. They were overwhelmed, and you know, you just need to look at the figures for excess deaths, and it tells you what you need to know. You can't really argue with that. So you know, excess deaths, coronavirus. Relative excess mortality in the countries we have examined ranges from minus 4.3% to 14.4%. So it is approximately 10% higher mortality than usual, and is strongly positively... I'd done my own calculations, which come to the same rough figure of 10% a while back, and is strongly positively correlated with the recorded number of COVID-19 deaths. Latvia and Norway experienced fewer deaths in 2020, as we would expect these countries to have recorded a lower number of COVID-19 deaths than other countries. A number of Eastern European countries saw little or no excess deaths in the first half of the year, but have experienced significant excess mortality in the second half of 2020. Bulgaria, Czechia, Croatia, Hungary, Lithuania, Luxembourg, Poland, Slovakia, Slovenia, with Poland and Bulgaria exhibiting levels of excess mortality of the same order of magnitude as the countries in the centre of the first wave. The USA, which has often been cited as the worst affected country, often using the total number of COVID-19 deaths as misleading because they're a big country with a lot of people, has relative excess of 12.9%, which, although is one of the highest, is below some of the even higher relative excess mortalities such as Poland and Chile. Relative standardized excess mortality is one method of measuring the impact of the SARS-CoV pandemic. It is superior to comparing total numbers of COVID-19 deaths and arguably more useful than comparing the COVID-19 death rate per 100k, as it overcomes the recording bias and measures both direct and indirect consequences of the pandemic, but it has limitations. We have noted that defining the expected number of deaths and thus the excess can vary to whether a 4 or 5 year average is used. In addition, using simple averages of historical mortality data could underestimate if there's significant downward trend in mortality or overestimated if there are upward trends. So I mean, yeah, it's not an exact science when you look at the excess, but it's a good clue. And basically the impact is roughly a 10% increase in what would be normal death rate. So there you go. Anyway, enough of that. The question I've got is that if in the end it is something that doesn't go away, are we all going to continue living in fear? You know, or are we going, or will we become more pragmatic about it? That's what I'll be interested in seeing. And then there's the other point, which is always kind of forgotten, that it's all very well to do what we've done, but the economic impact, it's really causing tremendous problems in some countries, like Italy, for example. The economic impact in itself causes death. The psychological effects of a lockdown situation will cause an increase in mortality. Basically, the medicine has side effects. The side effects cause mortality. It might be wise to ask the question, you know, are we being wise? I mean, here we can look at Sweden. They've had 744. See, they're the ones who didn't have a lockdown. They're in the situation where currently infected patients are a very small number are here's the daily new data. They had a second peak, look at that, which actually got quite high, but like point out that, you know, their death rate hasn't only sort of just touched 100 a few times. 100 deaths per day. How did they do it? Sweden, deaths per Sweden has a population of only 10 million, but their deaths per 1 million population . There we go. Deaths per one. Oh, come on. Oh, dear gosh. User interface nightmare. There we go. Deaths per 1 million population. The highest of all is Gibraltar. They only had 94 deaths. So you see, Gibraltar has a very tiny population, so you can't really count them. Czechia has a population of 10 million. It's third. Belgium came out pretty bad, but nothing like what happened in Czechia. That's like, and they have about the same population as Sweden. So I think a really good question is to ask is, what's the difference between Czechia and Sweden? And my theory is they had a consistent plan. The UK is not really done very well. The countries they've done worse than Italy. They had more warning. Italy was the one, people need to remember that Italy was the one that was hit without any warning. They could not learn from the experiences of anybody else. Other countries could learn from the experiences of Italy because it happened in Italy first. It's a conveniently forgotten thing, it feels sometimes. Of countries that are worse off deaths per million population than Italy, there are only two in the kind of European region. That's the UK and Belgium. And there's an interesting point, is what went wrong in Belgium? What Sweden did is that they stuck to one plan and they didn't keep chopping and changing. What the UK did wrong is they kept chopping and changing all the time. You know, either you do a lockdown and you'll stay in lockdown. You know, and we'll stay in lockdown until and we'll send children. And the other one is that doesn't make any sense. Is we'll send children to school though. It's like, surely children are going to be very strong spreaders of the. It's like chopping and changing your plan is worse than having a poor plan. Is it worth? I don't know. I think as the way it goes right now, I don't think that we're going to. Yeah, waterfall versus agile. But if you do agile. But you do agile on the basis of data, which is noise, that is worse than doing waterfall. You know. Anyway, look, that's enough. It's like this thing keeps going on and on and on and on, and doesn't make any sense. You have to remember, right at the beginning, in the early days of it, they were asking questions like, why is the death rate dropping? And we are... I wonder if we are reacting a lot to the original scare that we had. Yes, it's bad, but it really looked like people were saying there's like a 5% death rate, and then 80% of the population will get the illness, and they do the math and they say, look at this. It's like, But I think we're still afraid at that level, even though the danger has diminished. We get these peaks, but it's not like, I mean, as I was saying, in Italy, it looked like the death rate was 20% originally, which is just, you know. Yeah. Anyway, whatever. So what I was doing here is trying to do 1 in 16, and then I take the thing, I set the bit, and then what I want to do is, this is 0, 1, 2, 3, 4, 5, 6. So if I put 06 in here, it'll branch around it branches around this to get to here, and then, well, actually, can I just run this? What should happen is I should get a dot moving across every so often. We'll see if this works. So I have to enter this in. To B5 11 9510 E8 E0 07 D0 F7 E, and then we start E6. Increment the frame counter, right? E6 20 D0 02 E6 E6 21 E002 wrong way. Right, E620 D002 E621 A520 290F. So a mask off everything except the bottom 4 bits, and then branch if not equal 06 A517 0980 8517. I should be at 24. D002 E521 it should be E621. Oh yeah, E621 A520 290F D0 6 A51709 808517, and then this should be EA to say 30. For CO402 to branch back. Let's see if this works. 0200 go. Not quite. It seems that for a while, let's run that again. So I cleared them. Then there was a delay before it started, but I was expecting 1 dot, and it sort of filled them up for some reason. You know. So why did it do that? I'm loading increment the frame counter, in fact, A520 which is the frame counter address. Yeah, I mean, why does it do that? I shouldn't do that. And 29. Let's check the thing here. And immediate 29. That's what I did. And immediate 29. Branch if not equal around. Now what I actually see happen, debug this, because what happens is that yeah, for about 8 frames so debugging this is interesting because you don't really have any debug tools to keep going over it. Compare, right, so I'm looking at this right now. This is increment the frame counter, which was E6. We're going to check. Binary increment in 0 page is E6. That's all fine. Binary increment, and then you branch if not equal 02, but if it is equal, then you increment 21. You increment the next address. I load back the value in address 20. I do 2-9, which was the AND. Let's just check something, because I'm making an assumption that the AND operation actually sets the flags. Yeah, it affects the 0 flag and the negative flag, which is what I thought it did. Yeah. And it's 2-9. Immediate logical AND. There's only 1 in 16 frames when the result of this operation should be 0. Okay, here's a diagnostic we can do. What happens if I change that to 0? Then I should get them all the time. I don't get them all the time because briefly I get nothing. So what I can do is on 021A, we look at that, it's 29.0F. If I change this to 29.00, I'd expect it to immediately start filling it up. In fact, it is immediately filling it up. Oh, that made sense. Now, what would happen if I sort of made more bits then? So instead of 00, we kind of do 3F. It should take longer before it starts filling up. Oh, it does. I've just realised the bug. Aha. I was making the assumption that there was a problem with this, but actually this is working absolutely fine. The issue is nothing clears the first digit, and so then that bit is set. It's never cleared, and so the thing... And in fact, I put this note here, could just store if it's the first thing done, and in fact I will just store it, because then that storing operation will also have cleared. But then it's... even that's wrong. I need to always clear. So what I will do is look at the code from here onwards. I am going to copy that and paste it here. The instructions I'm going to put in here at this point. After hang on, not quite right. I moved the wrong. It's from here. This is the bit I need to move down. So what I'm going to do is copy that and then paste it here. And then what I have is 1, 2, 3, 4 things to fill in. And this is going to be an A9. Load the accumulator, immediate with 0, 85 into the left hand digit. This comments, I'm going to move them down. This left hand digit's 17. Okay. There we go. Oh, right. And for some reason, it went and cut that. Right, there. So, after doing the scroll, I am going to store 0 in that, so I'm clear right hand digit, which is the bit that was missing, and then the rest of it is the same. I'm just going to go into that here. I need to start at 0120, 0212, sorry, 0212, there we go. A9 00 85 117. A9 00 8517. E620. D002. E621. A520. 290F. Whoops. What does R do? I don't remember what that R button does. I didn't think about that. There's this R, there's the MLGRP. The P button was for setting a breakpoint. I can't even remember what the R button was for. Weird. I need to check that. But meanwhile, I hit the wrong button. So 1D A9 boat F D0 06 A517 0980 8517. Alright, that should hopefully fix it. I need to know what the R button does. See? That's more like it. And what does the R button do? There's the thing I was talking about, how it breaks down the buttons in that way. So what is the R button? It doesn't say. Acorn System 1 R button. What? This is weird. I don't know what the R... It must be in the manual somewhere. Right? Binary numbers inside the signifier. Remainder of the instruction. Acorn hardware. The keyboard and tape interface. 5.5. In the soft, all right. Some of the functions Acorn monitor. After the M, G up and down keys, the most useful keys will probably be S and L for saving a node. Okay, load a program. The breakpoint and restore command. The final two, I don't think I ever really used these. The final two monitor functions are embodied by the keys R and P. You may have already discovered that pressing R is disastrous and P is like M, but with a penchant for inserting 00 into the address specified. With these keys, you're expected to debug your programs. The P key allows you to insert the break instruction in top of an instruction at a point where you suspect something suspicious is happening, say 0200. After the address is set up, then any key will change the state of its contents. If not a break is inserted. The original data is saved in location 18. If a break, then the contents of 18 are inserted. So basically you can put a breakpoint in. What does the R do? So, using the monitor as usual, but avoid pressing the reset key. So I think you can. And R will continue the program. That's interesting. Hey, Mark. Oh, it's. I went for. I liked the vibe. So, but what the second camera is here on the Acorn System 1 display. This thing is. I had it set up, you know, good to see it, but I had it set up so that you could see both together, and the problem, but then I couldn't get that to work. The problem is that anybody looking at this just doesn't get any idea what it is I'm doing. So let me just try something. I set it up with a camera on here. This should become a little bit more obvious in a minute. Paste a reference. So maybe if I shine. That's interesting. Yeah, that doesn't work. Just bear with me a moment. I don't know, does that help? It's sort of like got a bit. So I basically have a camera mounted and I've got a little rig to hold the camera over the, oh flipping heck. Camera crashed, it always is doing that, properties. Oh, hang on. No.
Hello, Dino.
What? I didn't... When did I ask XP to be quiet? Oh, no, it's because he was talking about something to do with sex or I don't know. Why did I offend him? Sometimes he says things which are a bit sort of risque. Oh, flipping heck. There's certain topics which are just you can't. I can't remember what it was. It was something like that. I'm a rude I'm sorry. I'm a rude person. Okay. I thought I wasn't being too serious about it, but it was just that it was something. You know, sometimes it's like when it's saying things about. There are certain topics which are just not safe. So sometimes, you know, I hear that, I will say that to anybody. You know, it's like, you know, I'm sorry if, but I don't know. I can't know. I can't read someone's mind if I haven't been appropriate in my response. How do I know? There are certain things I'm not comfortable with, you know. Anyway, that would explain why everything's got really, really quiet. I mean, maybe everybody is. It's very interesting. It's like then. When Garcia leaves, everybody leaves. So I was just trying to sort of get a good sort of halfway house on this thing. Maybe I was able to get the whole like 4 rows of keys and the display in at the same time. You can go and look at the replay to know. Oh, maybe it's in here. Let's see. Let's look at the word. I'm sure egosexual is a thing. Right? So it would seem that as soon as I said that, I offended him. So I don't know. Sorry for saying, oh, be quiet. Is because that's the kind of thing it's unnecessary. So there we are. If there was an offence because I said, oh, be quiet. Sorry, mea culpa. I'm guilty. Let's try this. Brightness. So at least you can sort of get some idea of the system one here. It looks pretty, not very happy with the way that looks, but let's go and set the order and move it to the bottom. And you can't see it now, can you? So it'd be great if I could have two different views for the same camera. But anyway, great, Mark. Glad you could show up. It seems I offended Garcia, and he took all the audience with him. So I'm from Zag. I don't know. You know, you're on a stream. You're doing your thing, and then you have to say the things that you feel uncomfortable and that people might get offended at. And I didn't think I was nasty about it. You could always look at the replay and tell me. But in the meantime, Hal, play Mark's theme. Wait, are you Will? So Mark is Will Watley? Oh, so now I know who you are. I didn't know that you were Will Watley. I remember Will Watley. Cool stuff. So there was this main, right, now if I add another, can I duplicate, copy, I can paste a reference. Okay, well, if I go and set the order at the bottom, I suppose that works. You can. There is actually not a good way for me to. If I put on a crop, it does it on both. So this is the only way I can get kind of a zoomed in view. Oh my god, look at those. It looks like I've got dirty hands. Cool. Alright, so I'm going to run this. And so now you can see that you can see it when I'm typing. Right, okay, so anyway, there we go. I wish I could get a little bit better on the way it looks. Maybe I can sort of do this. No, blinding myself. I'll have to do. So, right. So what was I looking at? I was curious about that. So I've got my thing happening there. Look, it's struggling. So I'm going to not do this anymore. If I just remove that. Because it struggles with it. Properties. I think it's better just not to have it shown. I can configure the video and put it back the way it was, because then you could see it really clearly. But you can either see the display or you can see and then eventually exposure has disappeared. The exposure control disappeared. This software is terrible. Literally, that control just, it said, I've had enough of you. I messed around with the camera and now I'm paying for it. Look at that. Hello? Oh, jeez. Oh my God. Give me a break. I shouldn't have messed around with it. I had to unplug it. That's it. This is advertising your quality work here. Logitech. Look at that. So what I'm going to do is, I'm going to delete the main camera, unplug the camera, plug it back in, add a video capture device. Properties, deactivate, activate. Okay, is that going to be stable? Let's try and do a transform. We're going to flip horizontal and flip vertical. Order, move to bottom. Line it up. And then where's my display cap? Oh, this one. Put this back over here. And I can put that up so people can see what I'm doing. I suppose that will do. Right, it's still pretty bad. I'll put this. Right, properties, configure video. Advanced settings. Put the gain right down. Save. Okay. I think this is legible now. All right, and we can go and there we can see my game. Right, so this is what I'm trying to do over here, is write a game for the Acorn System 1. Do. So what I can do then is change the frequency of this by modifying the mask, because on this 021F For example, if I make it 07 and I go, it should be more frequent. There we go. Yeah, Mark. This is one of the projects. This is the first computer I ever owned, the Acorn System 1, and I want to make a game for the Acorn System 1. Quite interesting. I was thinking about how to develop the display, how to do the graphics, basically. I mean, what I've got is just that to work with. So right now, to give the sense of movement, I'm using the dots. So I just have a regular dot coming along. It's like, you could say, almost like a star field. It would be kind of nice if I could do I was saying earlier, it'd be kind of nice if I could do parallax. I suppose I could. But anyway, the other possibility I could do is I can use all kinds of bit patterns. I'm just thinking, can I? Yes, I can. How about making 2 at a time? So if I use a different bit pattern for that, so instead of 07, I could use 06. So that's going to be 0110, and then when I go, I've got 2. I could do C0. Oh, no, that's 0C I meant. 0C. So I can just do that with different bit patterns. It's quite nice. So that's actually quite flexible. Now, of course, I need to have my character. So how am I going to put that? The character, I'm going to put the dash of the left-hand side. So let's put the player. And A9. What was the bit for that? I have to look at the documentation on the display. This is funny. This is the preview. The Microsoft preview comes with the operating system. I just noticed something. If I rapidly hit the button, I can go through the document very fast. I can switch between them very fast, right? So you might wonder, why is it that if I hold the thing down, it moves slowly? The reason is because the auto repeat is deliberately cancelled to avoid the buffer building up. It's a really lame way of doing it though, because what happens as a result is that the auto repeat is now slower than if I do it manually. So lame, so lame. There we can see. Hex D3? No. ASCII code hex is 08. Right, yeah, so the middle one is 8. So the code I need is 08. So A908 85 11. So I'm going to put that in, and what should happen now is that I'll be adding well, it's going to create a tail for itself, as it will be 2, because I'm trying to do it on the one but. What's a bug? It's going to scroll after I put it down, so I'll need to also have a thing that clears it from behind so that it doesn't scroll. That's going to be interesting. I need to clear it before I do the scroll. Now we'll see, one step at a time. At 228. A908 8511. So we can see, it's the wrong digit. That's the one that's on the bottom. And I've also, I'm clearing. I should have ordered it, and I've stored it, so I'm losing the dots. But it's also the wrong digit. It's at the bottom. That's weird. Oh, 80, not 08, 80. Right. So what I want to do is do A5 11. The OR instruction is 09. It's not 80. It'll be 40. I think we'll try that one, and then A511. So what I'm doing is ORing. And it's going to, I've hit F7 as if that would work. Haha. 228. A511. So this is load address 11, which is the second digit from the left. Then 0940, which is OR that byte with 40, and then 85, which is store it at the address 11. Let's try that. So now we can see that the dot is passing under the thing, which is fine, but I have 2 dashes because it's scrolled, so now I have to figure out how to avoid that problem when the display occurs. I need to remember where it was and clear it. Yeah, I can do that. So then I need to know where the position is. So 22 is going to be player character. And the what I need to do is to clear you scroll, you put it, you display, you clear it. So I'll have to move this operation of where I run the display. I'm going to move it somewhere else. So what will happen here is display character player, display player, where, and I'm going to do a different version of this then. So that what I need to do is OR the player on, but I could always do that trick. I could do the exclusive OR trick. The great thing about that is that then I'm not worrying about like losing stuff getting deleted on the scroll. It's generally a good idea, and it's exactly how I did the players in Kickoff. I'm going to use the same technique here, I think. So 2.2 is going to contain the character. I can use this model then to do other graphics over the top of the scroll. So this actually makes a lot of sense. So the player character is here, and then what I'm going to do is load the player character in, so that'll be 22, and then I need to do an exclusive OR there we are on here, I guess exclusive OR it's a logical exclusive OR with at 0, which is 4, 5. That is the one that I need. Oops. So 4, 5 is logical exclusive OR with address 11. So XOR with address with second digit from left, and then store it. So this displays the player by flipping the bits which are stored in the player character. Anyone that's marked true in there gets set, because if it's blank it gets set. If there happens to be something in there, it's going to cancel it out. So this is what would happen also in Kickoff. If two players ended up exactly on top of each other, they would cancel each other out. But it has some very, very good properties that allow you to be very fast, and that's why I chose to do it that way. So I'm going to do the same thing here. It's hideously efficient, because now what I'm going to do after I've done that, then I'm going to plot update the screen, which I don't need to update it twice. So that's why I'm going to put NOPs in there. And then to avoid the problem of it propagating itself, I'm going to display the player again. Now displaying the player is literally 6 bytes. I might as well just paste them in again. Display again to clear. So basically exclusive OR the graphic of the player. It's exactly the same technique you can use in proper computers. It's just a point. It's the same technique. So what I'm going to do is exclusive OR whatever the shape of the character is on the screen, on the display. It appears. I draw the display and then I draw it again. But because it's being drawn with exclusive OR, where it reverses the image, Drawing it again will cancel it out, so it will disappear. But the beauty is any underlying graphics that were there are preserved, and this is a thing of beauty. So I'm going to just try that out. If I go back to memory location 0204, I'll see that I've got sort of that call to a subroutine. I'm going to EA, EA, and EA for on 4, 5, and 6, so that that's just, I don't have to remove all of the instructions. And then down at 2E, I am going to 22E. I'm going to add 208003. And then A522, A522, 4511, A5 8511, I got a bit confused here. Let's go back to two six 8517 A5 2 so a 28 A522. No, that's not right. A522 4511 8511. Right, 208003 A522 4511 8511 EA. And then 3A, we'll see 0402. Now something is bugging me about this. Let me check for 1, 2, 4, 3, C, D, E. Well, let's try it and see if it works. I've got a suspicion it'll. Okay. No, that does work. As you can see, the camera is stuttering again. That's so irritating. Properties on the camera, custom view. Right. So let's try this one instead. It's really annoying when the camera does this, because it's like you can't get an idea of what's going on. Yeah, it could be. Hang on a minute. You know, good point. Let me try and remove the main camera. Try it on a different thing that is shorter. let's add a new video capture device. Okay, there we are. Now I'm going to have to transform. I need to flip it horizontal. I also need to flip it vertical. I need to send it to the back, move to bottom. Let's see if this works better here. But as you can see now, if I hit reset on here, we can be, yeah, there we go. So as you can see, I have some scrolling action going on there. And it sort of cancels out the dot because the player character has a dot in it. But at least the player character isn't sort of like propagating backwards. I didn't set up what the character was. I didn't set up the value of this thing. Actually, funnily enough, I have some nice oh no, I need an extra byte in there. But I need to take a break. I'm going to, take a break. And I'll be right back. I'm not quite ready to give up yet tonight. What shall we have? I think let's have a bit of humming. That's the old humming. We need to have the humming proper one, the new one. Yeah.
When things don't work out, there ain't no need to shout. Just keep on humming, humming. When you're feeling small, hear the universe is cold. When there's trouble coming, just keep on humming. We're humming. We're humming. We're humming.
humming. All three of us. So, yeah. So, the character. Where is? Because I didn't set the character up. You see. So then I should have put some knops at the beginning, and I said no. Let's do it No. Oh. I'm a bite short. I suppose we can calculate what it should be here. We should clear it. I'm going to leave it. You know why? Because I can just put the value in for now. So it's on the player character as 0022 and memory 40. There it is. It's just a dash. For this endless runner. So we could have different states for the player character. A bit short of a bite. Is it better to be a bit short of a bite or a bit short of a nibble? That's the question. Right. So what am I going to do? I probably, if I press a button, can I? It would be kind of. Oh, look at that! It's stalled again. It's so irritating. This camera. I guess it wasn't that. It's not the one I wanted to do. Is like configure. What? Deactivate. Activate. So, right. What I want to do is have the thing actually on the ground, which would be, which byte is that? That would be zero, 08. It's on the ground. So that's fine. And then I want to be able to, I need to read a key press. So I also need to generate a jump. I need to make it jump. I want to make it that it jumps in the air. Oh, what would be a good way of doing that? Really cheesy way. I could look at. Right. 23. This is going to be the jump time timer, and I need to check how to read a thing. Right, so how do I read a button? I can look at duck shoot for that. Hit. How do I check? Oh, you should particularly notice that a jump to subroutine display returns with the carry bit clear and the accumulator holding the value of the key pressed for numerical keys. And the carry bit set and the values 0 to 7 in the accumulator for control keys. Ah, so actually, to read the key, all I need to do is look at the CP. The accumulator immediately has the address. So over here, I did the I call the display, and when I return from the display function, the accumulator has got the input. So I'm actually going to put a byte here. So this is the input system, stores a byte in 24. Well, will do in a minute. I need to do that immediately because this will actually, so 85 24, and then display the player again here. So what I'm going to do is put that in at, say, 022E 208003 8524. So I store the input at 24, and 45 is actually A522 4511 8511. So, right, this means I can read back the input at any time. Now, which keys shall I use? Say the 0 key for jumping. How do I know it was pressed? Let's read the instructions again. Oh, not that one. Ow. So, how do I know? Returns with the carry bit clear if the accumulator and the accumulator holding the value of the key press for numerical keys and the carry bit set and values 0 to 7 in the accumulator for the control keys. But how do I know the difference between key 0 and nothing being pressed? That's the bit that's confusing me. I don't get that. JSR display. I have to look at the operating system source code. Here it is. So when I do to OC display save X, does the scan thing. Check status. I means not processing a key. Get key digit back. Set status to we are processing a key. Has the key been pressed? Has it been be pressed? A hex key or not? Carry clear if hex. Put the key in a temp location. And return. So it returns, turn the segment drives off. How do I know? Yeah, it's a bit puzzling. I don't. Well, I have what I need in the duck shoot program. It should be doing this. It's sort of like, just understand it. Branch if equal hit only happens if we compare it with load x7 time JSR display, and it says it's hit if I compare the value I get back to what I stored in 20. What I store in 20 It doesn't really make a lot of sense. Returns with the carry bit clear and the accumulator holding the value of the key pressed. Well, I suppose what I can do is just test this by putting whatever I read back, feed it back into the display, and then I can see, because I can't figure that out from even the source code is a bit confusing. I'm going to write a test program for this, so I could do this 0270 here. We can go A9 1F 850E, which sets the thing up to not wait for key presses. Then I do 20 what was that again? 20 OC, yeah, 20 OCFE. OCFE, and then 85, we're going to store that into location 10, and then 4C 04 FF. Now that goes back to the monitor, so I want to actually go back to 4C 7002, so it jumps back to here. So this little, that'll do, it's fine. Could jump to there, doesn't matter. This will simply display and feed the result of the function which should be a key press, back into the first, the leftmost digit. 0270 A9 1F 850E 20 OC FE 8510 4C 7002. Go to 0270. So I can there, because of the fact that, oh, the camera's dead again. Just what? Ah, this is so irritating. You can see that now I'm running the program and we've got this shape. That is the shape that I'm getting back without a key press. Now with a bit of luck, when I press a key, we should see something change, but no. It doesn't. Oh, because the problem is, I think it doesn't, it's only going to read a momentary press. So actually, let me change the way this works. If I jump in, I'm just going to, right here, instead of, if I jump in straight to here, I can go 20 OC FE 85, and I'm going to store it, say in 20, which doesn't get wiped, and then 4C 04 FF. And if I go to 0274, it will wait for a press, which is what it's doing. It's waiting for a press. I hit the 0 button, and that should be back in the monitor, which it is. But if I go and look at 0020, I should see that it has 0 in there. Now if I run that program and I press button F and then I check the memory location, I have OF. So that is returning the button that was pressed. The question is knowing what is returned if the button is not pressed. So for this program, I can do memory at 0270, which goes A91F850E, so that's to set it up so it doesn't wait. Execute the display, store the result in address 20, then A91F A9 9F 850E to reset that back, otherwise it will screw up the monitor. 4C04FF return back to the monitor. So this one is going to run 0270 and immediately return to the monitor. It did, but it should have returned whatever value I get back 1F. So let's just check. If I put 0 in there and I go 1F, So what I think's going on is that if the value is bigger than 16, 16 bigger than F, it means there was no button pressed. It's invalid value. So I'm going to check that out with an experiment. 0270 A91F A50E OE20OC FE 20OC FE, right? Run the display program. We're going to compare the result with, I need the compare immediate instruction, which I don't remember, of course. Where are we? There we are. I'm going to look at compare immediate is C9. So I'm going to just type that straight in, do a C9, compare immediate with 1, 0, and branch if plus 1, 0 to FF, sorry, 0, FF, FE, FD, FC, FB, FA, F9, F9, A, B, C, D, E, F. Try that again. So, yeah, 1, 0. That's the value that I need to put in there, right? I go one more, and I have to count backwards from 0, FF, FE, FD, FC, FB, FA, F9. So I believe this needs to be F9. And then once that's done, 8. Yeah, we do A9, 9F, 850E, 4C, 04, FF. This program should wait until I press a key, then return back to the monitor. It's a bit weird. Okay. I don't think that's working right. 0270 A91F 850E 20CFE C9, compare it with 10, branch if plus that is not working convincingly. Oh, I think I know what I could do. Okay, so it jumps A9 F9, right, let's try this. FF, FE, FD, FC, FB, FA, F9. Alright, when it gets here, I can store whatever the value was that I got in address 10, leftmost digit, and then I can branch to 4C, and then whatever it is that I want. 4C, I can branch back to the beginning. 4C 7002. Okay, right, I've got something. So this program is waiting for a key press. When I press a key, it's sending that information straight in, and this is proving that it's working because it's checking for a value that is valid, and then when that value comes in, then you are F is the 4 bits that make that C. If I put 0, you can see 0, 1, that's the first bit, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. So that's proved that I can check for a button press in the code by looking at the result, which was placed inside address 24, and then I removed the player. Now I need to figure out the jump timer. So what I'm going to do here is say, you know, let's compare. I'm going to load A5, the input 24. I'm going to compare it immediate, right, which is C9. So we compare with C9 1 0, which is what I just checked. Now if it's positive, if it's plus, it means no key was pressed, so I don't need to do anything. So what I'll do is I'll do 1 0, which is branch with plus, and that will need to work out the offset when I know. Otherwise it means that a key was pressed because the value was less than 10 in hex. Right now I'm only checking for one value, so what I could do is put a hook in here though to make sure that I can add code later without having to shift everything. Well, we could start doing this with subroutines. Why not? So I can make it so that, yeah, I think I will. So what we do is we know that a key was pressed. I can check to see if it was 0 or 1, as I probably want to have, or 0 and 3, like 2 buttons. I feel like this game is going to have probably 2 button gameplay, so let's just detect those. So I need to see if the value that I got, the value is currently in the, hey, you know, I don't need to do it this way. I can just compare with them directly. I don't need to check if it's less than 10, or I'm checking 2 buttons. So check if it's 0. I could just avoid that, but this allows me the ability to change the button, so I'll do that anyway because it would have been set here in any case. Right. So if I do branch if equal, what was branch if equal? Branch if equal is, oh yeah, F0, that was right, F0, except I really need branch if not equal, right? So D0, and that's going to be 03, because I'm going to branch around a jump. That's a subroutine to, and this is jump. And in order to check for another button press, I can do C9 and then the other code, which would be 03, and then I can do this as well. So this is the input system, D003, and the address that I would go to in this case, and this is jump fire, you see. So that's input dealt with. And when I am done, well, actually, jump fire, I'm just going to put EAs in there for now because I'm not implementing that. But once I've checked for that, you know what I'm going to do is have another subroutine, because this will help. I can expand the code more easily without having to go. This is going to be a high. So everything that's moving along is the enemy environment. How's that? Enemy / environment, and I'll be that, and then I can just jump back. So there'll be a 4C, and I have to go all the way back to the main loop, 02, 04, or 02, end of main loop. So the jump input, I'm going to start at 0260. 0280 I'll do. Right, so 8002, and then so that the thing doesn't crash at here. .80. We'll put 60, which is an RTS. So when I press the jump button, it'll immediately return. So this is the latest version of the program. Well, it shouldn't really do anything new, but it will be detecting input, I hope. So let's give this a go. I'm going to go at, say, 022E, 208003, 8524, 8524, A522, 4511, 8511, EA. Why is there an EA? Ah, 39. Because this is the new code. A524. That's store the input key. C900 compare with 00. D0's branch if not equal 3 bytes forward, where I have 208002, and otherwise I can do another compare C903 for button 3, and display sorry, 3 EAs, EA, the enemy or environment, EA for now, because I don't have anywhere for it to jump to, and then the end of the main loop for C0402. For C0402. And mustn't forget that at address 0280, I need to put 60 for the return instruction. And we try running this, but I just realised that it might be good if I save this. Oh, I'll always type it in again. 0200. Well, the camera has crashed again, so let me restart this pitter. That's fine. Now the character was being stored. Player character was 22, I think. Yeah. 0022, where I'm going to put 08. So there you can see the dash of the character. Let's see if it crashes when I hit 0. No, it's not crashing when I press the buttons, so that's fine. But now I can put the code for responding to a button press here. The first thing I'm going to do is test. Always do a testable change. What's the testable change? I'm going to change the graphic on the key press. So that'll be A9 FF. Let's just light up everything. 85. No, it'd be interesting if I use 17, then whatever I put there will start scrolling down the screen. That'll be fun. And 60. So that's it. This is my test routine, which I'm going to put in, which is 0280 memory there. Okay, A9 load accumulator with FF. 85, we're going to store that at address 17, which is the rightmost digit, and then return. And now when I press, there we go, look at that. But interestingly, it only seems to do it every other time. It doesn't do it every time. In fact, stop doing it. That's not reliable. That's a bit disappointing. You should do it every time. That is very disappointing. Indeed. So I have unreliability. When I press... Now it's going to be a bit tricky to understand. I'll have to probably study the operating system source code on page 40 or something. Well, why does that not work? It should work. I run the display. Let's have a look at the no. Single scan routine. Cleared the display. Okay. Put the new doc on. Load X. Immediate with 7. Store AZX 10. It's weird because that's oh right, yeah. Store AZ store X 0 page 20. So that's the particular duck. Oh. No, I figured it out. What it is because I'm calling the... Oh, classic. This is the equivalent of checking your input for a key press in Unity and you checking it inside a fixed update and then wondering why you have unreliable key presses. Yes, you see, it's not a lie when I say it's all the same patterns that you get in modern game development. You find all the way back here. If you've ever worked in Unity and had a problem like that, it's a classic pitfall, because what happens is that the routine, the input routine, is looking, it has this call to check if you've just had an input trigger, so it's just pressed to go high or low. It just happened, right? But it only works if you check for it inside of the normal update and not the fixed update, because if you try it inside fixed update, it's possible that it will have called the main update more than once between the times that you check in the fixed update. If that happens, you can miss the fact that there was the key press. So believe it or not, what I have here is a bug that's identical in its nature, even though I'm working on hardware that's 40 years old and I don't even have a screen. So there you go. You know, it's like to that person, you know who you are, who said, yeah, well, the problem is with him that he's just stuck in doing 8-bit programming. This was a student. It's like, the point I tried to show, and I can't, obviously I didn't do a particularly good job at it. I'd love to know if there was a better way, if it was even possible to express it, is the fact that in the art of computer programming, nothing really changes that much, and that there is a lot of value to, you know, studying the older stuff. And furthermore, if you have somebody who knows about the older stuff, it doesn't mean that they don't know anything about the newer stuff. You know, that's crazy stuff. I remember all this stuff and I live with it forever. That's my curse. Like an elephant, never forget. The scars of a lifetime. But here we are. So the problem is, what is it? The problem is that the routine that I made to do the update. It's coming up any moment now. This one, this very short one, it calls 200CFE, the update thing. Hey there, Adam. Good to see you. You know, I call it multiple times in order to slow the game down, which means that if I'm lucky, I happen to press it on the 8th time. So in fact, 1 in 8 times, it's going to work. Because if I press it during any of the others, by the time it exits, it won't have remembered that the button was pressed. Ah! Yeah, you saying that's also true in other, you know, in the wider field. I'm sure of it. It drives me nuts, as many things drive me nuts. Well, eventually, there was a paper in 1964 by a guy called Conway, not related to Conway's Game of Life, introducing a concept of coroutines. We still don't have them properly, sort of like 60 years later. We still haven't. What the hell? And you know why? It's a tragedy, because the easiest way to implement coroutines was to use a computed go-to statement, which Fortran had. And then there was that stupid damn thing, go-tos considered harmful, which isn't even what Dijkstra was saying, but was put on as the equivalent of clickbait by someone. So for the purpose of clickbait, the one thing go-to considered harmful completely changed the whole direction of computer science, shoved it in a certain direction, which meant that people started saying that go-tos were bad, and then because of that, Fortran started to find itself being chucked out. But what got thrown out as well was the computed go-to that Fortran had, that if you had computed go-tos, you could so easily implement coroutines, as I implemented in 1991 or so, without knowing they were called coroutines. And I did it using macros in 68,000 assembler, computed go-to, to create a statement that said, from now on, skip me and execute from here, which is in a sense what a coroutine actually is. And that is the reality of the human condition in computer science. That is the truth. Not that we are rational human beings that work together as a team to advance things in a rational way. A damn headline of a paper by Dijkstra written to make it seem more controversial had the ramification that we still don't have coroutines in C++ 60 years later. Thank you. Drop the mic now. There we are. Ah. 1 in 8 times better than Microsoft. Well, thank you so much, Mark. Yeah, well, that's a very wise statement, Mark. The irony is that it's been said, and I think there's a great truth to it, that every single programming language, as it evolves, sort of asymptotically approaches Lisp. There's a name for that one. I don't remember it. It's like we are. The whole process of computer science can be viewed, and computer engineering, really, it's not really a science, let's be honest. But if the whole thing is basically a very, very long and convoluted process of rediscovering Lisp all the time, over and over again, as a Groundhog Day. You are so right. could a language like Lisp even be written today by people who are not familiar with the language of Lisp originally? Probably not. Are you a better programmer if you have some grasp of how Lisp works? Yes. Lisp is actually a very elegant language. It has a beauty. It can get sort of corrupted, like all languages can, but in its core, it's a very pure and beautiful language that has a simplicity that's unrivaled. However, it is still a procedural, so imperative language in the end. But you are absolutely right. We're losing the ability to do computer science. Or we may have lost it. Computer science it's not something that it's like all science is, it has to have roots, and you have to respect the roots of science to be able to advance it. If you're a mathematician, you have to respect the Pythagorean theorem. I mean, you just do. But in computer science, and it's sort of like, think of the 3-4-5 triangle, or relate the story about how they could measure 90-degree angles on buildings by using a piece of rope with 12 knots on it, because you could lay that out as a 3-4-5, because that adds up to 12. And if you construct a triangle like that, you know that there's a right angle. And that was used by ancient builders when this was figured out, was the way they managed to make sure that the corners of buildings were actually at 90 degrees. It's a beautiful thing, right? But the point is understanding that really helps with your understanding of mathematics, right? But we don't do that with computer science. What we do with computer science these days with the training of programmers seems to never go there, because what there should be is a wonderful exploration of all languages that have been developed up to this date. In fact, I'd be interested to know if there is such a thing as a course in computer science which is the history of programming languages. If there, you know what? If there was, maybe they do exist. I should have a look. But you know what? If someone was doing a course in the history of programming languages that wasn't just thrown together, but was from someone who's an expert in that subject and could piece together the way and show how the languages evolve one from the other, and I'd love that. That would be beautiful, because to understand how we got to a certain place is probably more important than being there. Because if you're there and you don't know how you got there, you are lost. Jeez. But that's how I feel it is. And that's part why I'm doing this crazy thing here. I feel I lost it. I was programming 40 years ago on this thing. And it feels good to be programming on it again. I feel like I'm learning things. What am I learning? I'm reconnecting with what made me what I am. And computer science needs to do the same thing. It needs to reconnect to what made it, its own history. But you go and it's like all you need are algorithms and OOP, and teach Java, cookie cutter programming, where the IDE dictates the architecture to you. That's sad. History of programming languages. Yeah, it certainly would. So you once had a producer tell me that programming is if, buts and maybes. Programming is if, buts and maybes. It's funny, you wouldn't say mathematics was if, buts and maybes, but the truth is that computing or computer science is a branch of mathematics. Oh dear. We shall not cease from exploration, and the end of our exploring will be to arrive where we started and know the place for the first time. Oh, yeah, where's that from? I actually don't know. Anyway, the point is, I found the bug. The bug was due to the not, because I call the display routine multiple times to slow things down. It can miss. So I need to figure out how to resolve that. Now, if a button is pressed, I'm going to get a value less than 10. So I'm just thinking the effective way. What I need to do is, well, I could, and so which button do I take? Because there could be multiple presses. So it should really be the first one. I could thing clear a memory location. Well, I actually want to store it in the input. I did create something for input, right? So the fix is to take that check for input, or after calling this routine, where was it? After the this call, which calls my routine, not the operating system one, I save the result and then I check. So what I can do is just say, you know, we store it here. That routine will store it in here. So that's means that I can get rid of that. I'll put NOPS in there. And my multiple calls here, I need to sort of start with something else. So let's try take that and move this down a minute. And the first one is A90085, and this is going to store it in input, which is 24. What address? It was 80, which seems to wherever that is. 380 is all the way over here for some reason. It's just kind of moved. Right. So the first thing I'm going to do is A900. So I load the accumulator with 00, and I store it at address 24, which is the input device, the input address. And I do that, but actually, no, I don't do that. What I do is I store 10 in there, because that is for no button press. Then I load the index register, no, the X register with 8, and then I'm going to call OC FE, and the result of having done that is that the accumulator is now potentially going to have a value of less than 10. But I need to check what the value is again. So after having called this, I've got a value in the accumulator, and I need to compare it. So all right, let's do this. To compare immediate, can't remember. Compare immediate. It's this table. Compare immediate was C9, of course. So C9, and we're going to compare it with 10. So the question is, did I get a key press? I branch if not equal D0. So this means no key press. It branches if no key press. If no, wait a minute. It was branch if plus. Oh. Branch if plus. Right, 1 0. So 1 0 branch if plus, which means if it's plus, it means that there was no key press. If there was a key press, then I need to see if this is actually annoying. Let me check the chat. Oh, it's T.S. Eliot. Ah, very good. I've never really read any of his stuff, as you can tell. But I know the name, you see. So there we are. Yes, I've heard of T.S. Eliot. There we are. The history of stories. Not my forte. So if I do C9, 10, right. So the problem is I need to check if an easier way than messing around with, I need to check to see if it already had done, and if it hadn't done, then is to actually just make 2 loops. It's actually easier in this case to do 2 loops. So first of all, I will store a value which is invalid in 2.4. I will put the thing in the accumulator here, in the X whatever, and then I'm going to check the X register. I'm going to check to see if I have a valid result. And instead of branch if plus, we'll do branch if oh no, it is that. I branch back. So that's FF, FE, FD, FC, FB, F9, F8. I think it's F8 that I need here. So what F8 does, so there's FF, FE, FD, FC, FB, F9. Oh. FF, FE, FD, FC, FB, FA, F9. That's right. F9, not F8. F9, FA, B, C, D, E, F. Yeah. So this jumps back. So we jump to the function until we keep jumping back to that. Oh, that's not quite right, because I need to also do the decrement X. Let's do branch if minus. Now branch if minus is 3 0. I'm going to change my mind. I'm going to jump. When I've pressed a button, it's going to jump out of the loop. Otherwise, I need to decrement, which is 8E8, and then decrement X, and then branch if plus, which means I haven't finished yet. D0. That's branch if plus. D0. And I have to go back from FF, F, E, D, C, B, A, 9, 8, 7, 6, 5. So this is branch back F5. So I put 8 into the X register. I call the display routine. I check to see if a button was pressed. If the button, that's compared with 10, if the button has been pressed, which is branch if minus, I haven't decided that yet. Otherwise, no button press, I decrement X and then branch back to 5, 6, 7, 8, 9, A, B, C, D, 5, 6, 7, 8, 9, A, B, C, D, E, F, F4. You know, I need to take my special thing here, this thing, and make sure I can just put that in here, and that didn't work. Hey ho. There's probably a buggy one. Let's try this. Come on. Here. On this thing. There we go. Boom. It comes back to 3, 9, 4. It's gone forward. This is not going well. Oh, what's it doing that for? Oh, that was a corrupted one. And this is the shortcomings of. No, that's corrupted. No, no, they're all these. They're all corrupt. They've all got messed about. All right. Well, let's have a look at that. This, no. This should be 352. Why are we even still using spreadsheets? I mean, surely there's got to be a better way, but nobody's able to invent a better way. But let's see, we go 0384 and it comes back, and that is too far because I've gone back to where I am setting the value of X. What I need is F6, jump back to 386 on there. Okay, so if we arrive here, it means that we ran out of time, and so run out of loops, and so I'll just put a return statement in there. The jump forward from here is to 0, 1, 2, 3, 4, so this should be 0, 4, so that it jumps to here. When it gets to here, it means that a key press had occurred that was valid. It is going to be in the accumulator, so I can then save it using 85 at the address 24, for which isn't guaranteed to happen, but that's okay because I already initialized it to a value that is invalid. So this saves that, but now what I need to do is finish the loop off. Because I got here, the loop is not finished. I haven't called it the correct number of times yet, so I go 20 OC FE, so I call it again, and I do a decrement X, and then I branch if plus FF, FE, FD, FC, FB, FA. So that's FA, and then 6 zeros. So this is the new routine, which is call display multiple times and save any key press along the way. So all of that sounds very fancy, but it's like practically two lines of code in C. But one of the great things about this type of programming is you think very carefully about those 2 lines of code. You know, I think there's value in that. Instead of taking things for granted. So, this is actually the screen does the lighting here. Anyway, let's see if this works. I'm going to type this in. 0380 and there we go. A9 A910 8524 A208 20 OCFE C910 3004 88 D0F6 60 D0F6 no, I think I got that wrong. 60. Yeah. 8524 20 OCFE 88 D0FA 60. And we're going to check it. A9108524 A20820OCFE C910 300488, that's decrement X, D0 branch if not equal, F6. Return. If the result was minus, it jumped forward 1, 2, 3, 4, which takes us to the 8524 store accumulator and address 2420 CFE. Call the display routine decrement text branch if plus FA from FF, FE, FD, FC, FB, FA. That looks correct. 60 RTS. This should be a drop-in replacement for the previous call. I mean, drop-in replacement. It should work the same. However, there was just that one point about the thing that is changed here, which is that when I make the call to display, which was 022E, I'm expecting 2080. There's this 8524. And that should now be EA. Because the accumulator will be destroyed by the loop that continues to call the required number of times, which is why I saved it into an address. That should fix the problem, I hope. Let's see. It crashed. So that's the first crash I've had. actual crash. I've had very few actual crashes, but that was an actual crash. So normally what I would do at that point is just go check the code. A91F850 EA A200 B5109510 E8 it didn't crash. Why did I say it crashed? You can always tell when it crashes. That's not a crash. If it crashes, you don't get... When it crashes, you don't get more than one digit lit. That's actually not a crash. It's a bug. Google Sheets considered hard. Very good. Yeah, that is not a crash. What happens if I... Yeah, that's very strange. So I can only assume that what happened, if I'm looking at the behaviour, is it has modified... It has attempted a scroll. It has modified that digit. I think it's stuck. It's basically never. It's never exiting this routine. And why would that be? And like C9 04. Say, wait a minute. 88 is decrement Y. I'm using the wrong. It's CA is decrement X. My memory, my incorrect memory, 0380. So it still didn't crash though. But what I did was I decremented the wrong thing, which means X never got decremented. And because X never got decremented, it did indeed never exit this function, this subroutine. There's another 88. There it is, and we can put in CA in there. And that's good. So we'll try again. Ah, right. That seems to be operating. And when I press 8, when I press the 0 button, I get a digit come across, and that works every time now. I consider that a success. So I made a bit of progress. I think I can see how I can actually end up making a game that's fun, which is the mission here. I can make a game that's fun that works on a calculator display. And it's funny how it just feels like game development. And yeah, I mean, look how compact the code is. Have we really been making progress? It's amazing to think. It's a bit extreme here, doing hex, programming in hex rather than assembler. But anyway, I think what I need to do right now is save this. Oh, okay. To save, I've got to sort of fiddle about with wires here. Did I have a... I seem to be missing a wire. Well, alright, well, I'm not going to bother too much with the niceties of it. I'm just... Well, I can use this one. It's fine. Right, so... In order to save this, I need to connect
the cassette output, and then I need to wrap these because I was having problems finding the right solution for connecting these. So I think, oh, hang on. Oh, come on. I didn't want that shorted there. That's it. So I'm connecting up the cassette port to the sound card by wrapping wires here. Sometimes you just have to do it like that. Sometimes there's no other way. Right, so that's wired up, and I'm just going to try to record it. If I click, oh look, I have a nice signal there. That's good. So let's start with a new project, and I'm definitely recording something. Does it look like it looks wrong? Yeah, I'm recording. Yes, I'm definitely recording something. I am recording hum. Yeah, that's not that's not going to work. Yeah, hum. Oh, hum. Seriously. Hum. Oh, yes, you can see it when I touch it. I've got the wrong channel. Right, let's connect. I've got to wrap because it's like our stereo output, but stereo input. Of course, the thing is that everything I typed in now is in jeopardy, because if I lose power to this thing, I'll have to type it in again. And oh, that's a nice loud signal. And wow, yes, it's a bit. Let's have to reduce the volume level. Yeah, it doesn't look like I can. It's like recording volume 0. It's still maxed out. Yeah, well, that's a signal. I think I want to try and reduce the open sound settings, sound control panel. There we go. Recording on USB levels. Jeez. It's like I put it at 0. Advanced levels, custom, AGC. I've turned off the AGC. Then it seems okay. That's a little more reasonable. There's the square wave of the. Okay, so we'll stop there. And I need to save now. Instead of bothering about which bits to save, I'm just going to save all the program memory from 0200 to 0400, and let's hit record and press save. Blue tack. Yes, there's blue tack under this to stop the camera from moving.
Oh, wait a minute. The camera just died. Yeah. Brilliant. Just because it keeps doing that, doesn't it? Properties, deactivate, activate. There. So it's been saved. The real question is, this is always a little bit nerve-wracking because, you know, it's never gone wrong since I got it working properly. That's all of the program. That's 512 bytes encoded, frequency shift keying. So let's just save it. Save project as Infinite Runner 2 and save. And to test this out, then I need to play. Got this set up correctly, and I'll hit. There is no verification, so it could wipe things out, but frankly it's probably going to work. So we hit that and on load, and we wait, and the bytes are coming in. And that's back, and that's good. And then we just check what happens if I run the program, and that's it. And then I hit 0, 8. Oh look, you can, every time I hit 8 we get another character. That's my environment, that's my scrolling, for my side scrolling, for my Infinite Runner. There we go, on a calculator display. What fun. I can make a lot of money out of this. Yeah, well, it was funny. It's a laugh, but when I was playing with it like 40 years ago, I ended up making a lot of money. I mean, making a career out of it. So I suppose it's not really that funny. That's saved. Cool. It's late. I've got to go. But time for a video. We had humming before. I think it's time for I Only Want to Sing the Blues. Why not? Have a good night, everyone. Cheers.
Heads away and
Yeah? Really? Man, I can't do this anymore. You know they're watching me. Look, I know, all we want to do is play music. But man, I mean... No, I'm out, I can't. What? Oh, come on, stop messing with me. No, I don't believe you. Oh man. Okay. Yeah. 1:30 tomorrow. Got ya.
Please hang up. Please hang up.
Hello Dino.